It is that time. Welcome to part 4 of Let's Get You Coding Challenges. In this section, I'm going to solve challenges that are relating generics. So we're going to talk about generic, I'm going to be solving generic array challenges, generic functions, object types, function inference, and a lot more. See you inside the section. Hi everyone, welcome to your very first challenges solution for generic arrays. The challenge statement says that we need to create a generic array of strings and pass in some values. So let's go ahead and let's create that. These are very simple. I'm going to start with let, and it's going to be my array. I'm going to type annotate this. I'm just going to do 2 colors. We want to have a generic array of strings, and we want to pass in some values. So I'm going to say array. Since this is generic, we need the angled bracket, and it is only going to accept strings. All right, let's go ahead and let's pass in values. I'm going to do A, I'm going to do B, and then C. That's it. That's it for this challenges solution. See you in the next one. Hi everyone, welcome to your second challenges solution for generic arrays. The statement for this challenge reads that we need to create a generic array of 2 Boolean values. Let's jump in and let's see how we can do that. I'm going to start with the let keyword, and I'm going to say we have an array. The name doesn't really matter. The generic array has to have Boolean values, 2 Boolean values. So first, let's write the array keyword, and then the generic syntax, and within the type of the array, I'm going to pass in Boolean. And now let's create our array. Within this array, we can only pass in true or and false. That's it. See you in the next challenge. Hi everyone, welcome to your third challenge solution for generic arrays. The challenge statement says that we need to create a generic array of an array of strings. Let's go ahead and let's create that. I'm going to say this is let my array. Everything lies within the type annotation. We want to create an array of strings. So first off, let's start with an array of strings, generic. This is going to be a string, and then we want this to also be within an array. So this entire thing will also be a generic array, and that's it. So it's an array of strings. Let's see how we can use that. Now within here, we cannot pass in like individual items like 1, 2, 3, like A, B, C, D. No, everything that we can pass within here, it has to be an array. So this array's items has to be arrays, and those arrays can only contain strings. So this is one array. I'm going to say hey, and then you, and then these are actually commas, and then good. And you could pass in another array, but I'm just going to stop right here. So this is an array of strings. See you in the next one. Hi everyone, welcome to your fourth challenge solution for generic arrays. The challenge statement for this one reads that we need to create a function whose return type is a generic array of numbers. And we need to add some values as well. Now, before starting this challenge, I need to tell you that there is actually more than one possible way of solving this challenge. So if your solution is different than mine, it doesn't mean that it's wrong. It just means that you have taken a different approach that I highly encourage. So let's jump in and let's see how we can solve this one. We need to create a function. So for that one, I'm going to need the black this marker as well. Let's say function, and this function, it could have any name, and the name that I've given it is going to be some array. It's not going to have any kind of parameters, and everything lies in the return type of the function. It is a generic array of numbers. Everything is okay so far. Let's move on. And we are asked to add some values as well. So what I'm going to do is, again, this is where the solution diverges. Converged, yeah, diverge. And it could be like more than one solution to this. You could add a parameter, and then you could populate that parameter. That could be an array, and you could populate it outside the function. But I'm going to do it within the function. I'm going to say let num array. I'm going to initialize the array right here, and then I'm going to get num array dot push. Let's add number 15. Keep in mind, you can't add a different value. Now, I could type annotate this to an array of number. In fact, go ahead and do that, but I'm not. I'm just going to say num array. I'm going to keep this simple. Since this red one, this is the focus of this challenge. Push 35. And finally, we want to return num array. So when we return it, what do we have? We have an array of numbers. And that's it. That is the solution to this challenge. See you in the next one. Hi everyone. Welcome to your fifth challenge solution for generic arrays. The challenge statement says that we need to create a function that returns a generic array of an array of numbers, and we need to add some values as well. As you might have noticed that I have the solution from our previous challenge, and I'm going to modify this to account for this challenge. The first thing that I'm going to do is I need to pass in an array of numbers. So this is like written very large. I can just write it there smaller. So we have an array of another array, and this nested array is going to have items of only type number. Cool. And I'm going to pass this one right here. Now, since we have done that, up until here, the logic is going to work up until here. But when we return this num array, the logic is not going to work. Why? Because this num array is an array of numbers. It's not an array of numbers. So what we have to do is when we push these two values, we need to make sure they're not just values. They're not like just numbers. They have to be an array of numbers. So I'm just going to give them the syntax. This is the syntax. And I'm sure it's a little bit hard to read, so why not write them from the start? So I'm going to push 15, and then I could push 35. And that's it. This is the challenge solution. See you in the next one. Hi everyone. Welcome to your sixth challenge solution and for generic arrays. And the challenge statement says that we need to create a function whose return type is a generic array of an array of strings, and we need to add some values as well. I still have that example, and I'm going to make changes to it. The first change that I would like to do is this angle bracket is too big. Let's make it smaller. And it has to be an array of strings. And this no longer is a nums array. This is a str array since it accepts strings. And I'm going to get rid of these items in here as well. Since they're numbers, we need to pass in strings. And now let's modify this. First off, let's take a look at the type. It has to be of type string. Now let's add the angle bracket. After that, I'm going to pass in str array, and then stir array here, and stir array here, and then we return that from the function as well. Now, what are going to be the values? I could, since this is an array of strings, I need to pass in the values in an array format. I did actually forget to put the ending bracket in our previous challenge, and I am going to make sure to put it in this one. And let's say this is Java. And there we go. So this is some array, an array of strings, and then we push these values to there. And so at the end, what we are going to have is within this array, we're going to have one array of TS, the other one is going to be JS and Java. I think, yeah, that should be it. So see you in the next challenge. Hi everyone, welcome to your 7th challenge solution for generic arrays. The statement for this challenge says that from this generic array, what we need to do is we need to extract the value of TS. And I'm going to let you take a look at that for like a couple of seconds. So this is an array of an array of an array of an array of string or type number. So it's like 4 levels deep. This array, which is this one. And I'm actually helping you understand this. So we have 1 array, 2 arrays, 3 arrays on the outside. And that's why we have 1 bracket, 2 and 3 on the outside. And then we get inside right here, which is this array. And then we have an array of string and number. So it could be an array of number. We could add number, we could add strings, and like that. So what we have here is, I think I've gone over this. Should I go over it again? So within the innermost array, we can have an array that can have string values or it can have number values. And that is this array. So this array of string is this one. Array of string, and then an array of number right here. And then this array of string is within this array, since this 1 level up bracket, and then that is within this array, so we move there, then we move there, then we move there. Cool. So now that we are on the same page, let's see how we can extract the value of TS from this array. First of all, we need to reference the array, some array, and we're going to use the bracket notation. And for the first array, as soon as I do that, I'm within here, I'm going to select the first item that has an index of 0. Let me just think about it. So when I say index of 0, I've actually selected this array. Since I am within the first array, I have selected the first one right here. This has been selected. And I shouldn't write a number there. I should provide perhaps like a tick mark that array has been selected. So like that. So that array is selected. And let me just put the blue down. And then we need to move within this array. And within this array, I'm going to do 0 as well. As soon as I do that, this array is selected. Now that this array is selected, we are within there. Which element do we want to select? Which array has the item that TS? So index 0, index 1, index 2, index 3. So let's say index 3. Index 3. And this effectively selects this array. So far everything is clear. And finally, from this array, now that we are here, index 0, index 1, index 2. And as soon as I do the bracket notation of index 2, this is going to give me the string TS. That's it. That's it for this challenge. See you in the next one. Hi everyone. Welcome to your very first challenges solution for generic functions. The challenge statement reads that create a generic function that returns its argument, and we should also test with multiple values. Let's go ahead and let's create that. It's a generic function, so I'm going to say function. It could have any name since this function returns its argument. I'm going to go with a very clever name that is going to be return arg. So far everything is making sense. Now, since this is a generic function, I should not do this. Remove the G as well. Let me fix that. We need to pass in the generic syntax. And the generic type, as we have talked about before, is going to be T in this case. And the parameter is going to be called elements. Elements. And the type of elements, since this is a generic function, the type of it is going to be T as well. And the type of this function, the return type of the function, is going to be T. So let me just close off the function here. So now that this is done, the only thing that we need to do next is just to make sure that this function returns elements. It does nothing. It just returns its parameter. And we need to test with several different values. Of course, I can test it here, but I know I have to write something here. So we're going to get the return arg function, and what I could do is I could pass in a string. I'm going to get the return arg. I'm going to pass in, let's say, a number. I'm going to get the return arg, and I'm going to pass in some sort of a Boolean. So this one, I'm going to say HTML 115, and this one is going to be true. And that is it. That is the solution to our challenge. See you in the next one. Hi everyone. Welcome to your second challenges solution for generic functions. The statement for this challenge says that we need to create a generic function that returns the length of an array. And we need to test it several times as well. So let's go ahead and let's create that. I'm going to say function. It returns the length of an array. So return length. And this is a generic. So we need to do it like that. I'm going to pass in T here. I'm going to do elements. It accepts an array and returns the length of that array. So when it accepts an array, I need to type annotate it like this. And then it returns the length of an array. So when it returns the length, what it means is that it returns a number. So let us fix that. The parameter is going to be elements. And then this is going to be the function's return type. Very cool. So what does it do, the function? The function says that I am returning the elements dot length. So I'm returning elements dot length. And now we need to test it. Again, let's just go over the function. It's a generic function. It accepts an array and it returns a number. Why? Because it returns the length of that array. So let's pass in some arrays and let's test it out. I'm going to say return length. And it accepts an array. So we need to keep that in mind. This is one array. Let's pass in the values. Let's say the values are HTML and CSS. These are the values. This is the first array. And as soon as we pass this, it's going to return 2. I'm going to test it one more time. So return length. For this one, let's do, since this is a generic array, we can work with strings. We can work with numbers. So these are not nines, these are commas. Look like 9, they're actually commas. And this is going to give us 4. And let's do one more. Why not? Let's do, oh, come on, buddy. I have a lot of juggling. I'm juggling a lot of markers. So length, and cool. So for this one, I'm gonna do true, false, 10. You know what? Let's do 1, and then let's do 10. And then I'm gonna do a string of A. So since, again, these are not union types, in case you're wondering about them, this is the number 1. Cool. Since this is a generic type, and we have not actually specified right here after we have created after we have referenced the function, we can pass in booleans, numbers, and strings. And this is gonna give us 1, 2, 3, 4, and 5. And number, elements, yep, we're done. That's it for this challenge. See you in the next one. Hi and welcome to your third challenge solution for generic functions. The statement for this challenge states that we need to create a generic function that accepts an array of strings, a generic array of strings. I should add that generic key there as well. Keyword, and it returns the 5th item of that array. Let's go ahead and let's see how we can create that function. I'm gonna write here first the function itself. The name of the function I've selected as my stir. You can do whatever you want. My stir, and this is actually an angle bracket there. It accepts an array of strings, and let's make sure that it does. We are going to have elements, array of strings, generic array of strings. You can do like a normal array of strings, that is going to be fine. And it returns the 5th item. Now this is string, right? And we want to return the 5th item. So what we are actually trying to return is actually a string. And this T represents a string for us. So when it represents a string for us, it's better if I just access that T here as well. Right? So even though this is like a generic, you can pass in numbers as well, but we just want to work with strings for now. And the function returns a string as well. Let me pass in elements. And everything is okay. Let's create the function body. Cool. Let's return. How can we return the 5th item? It's very simple. First, we access the elements array, and then using the bracket notation, we can access the 5th item. Now, keep in mind, the 5th item or the 5th item has an index of 4. So I'm just going to add in 4 here, and that is it. Now we can test this using by calling the function my stir, and I'm going to pass in an array, and let's say I close it off right here. Could do that, right? I'm going to pick it up later. This is going to be A, comma, B, comma, C, comma, A, B, C. This is going to be D, E, and I'm going to add F there as well. So what is it going to return for us? The 5th item, 1, 2, 3, 4, 5. And it is going to be E. it doesn't have an I, but I'm just gonna do it like that. So it is index 0, index 1, 2, 3, and this is gonna be index 4, item number 5. That is it for this challenge. See you in the next one. Hi everyone. Welcome to your 4th challenge solution for generic functions. The challenge statement says that we need to write a generic function that accepts a generic array, returning the last item of the array. So let's go ahead and let's check that out. I'm going to create the function right here. And the function, it could be some func. I'm just going to call it some func. And some func. We have talked about this syntax for a generic. It could be the letter T, but it could also be the word elements with the E capital. In this example, in this challenge, I'm going to use elements. Elements. There we go. Keep in mind that the function parameter is going to be called elements as well. But the difference is that the function parameter is going to have elements lowercase with a lowercase e. Elements, there we go. Let's type annotate this. Now this accepts a generic array. How can we write a generic array? You already know that. Now this doesn't accept an array of string or number or boolean, accepts all of them. So I'm just going to pass in elements again. Wherever we used to pass in T, we are now passing elements. And the function's return type is going to be elements as well, whichever element that may be. But we want to access the last one, so we are going to write our code in according to that. Return. Now, to get the last item of an array, we need to tap into the world of JavaScript. Let's do it. I'm going to get the elements. First, reference which array it is that you are working with. Bracket notation. We are going to get elements dot length minus 1. So elements dot length is going to give us the length of the elements. Minus 1 is going to give us the ultimate, the last item. So from this side, if we count, we start 0 in this index wise, 1, 2, 3. But from that side, if we count, we say minus 1. Minus 1, minus 2, that's why minus 1 is going to give us the last item. And now we need to call this function several times just to make sure everything works correctly. I'm going to say some func. Now I'm going to grab the generic syntax. Some func, grab the generic syntax. Some func, grab the generic syntax. For the first one, I seem to have passed in a number. For the second one, I'm going to pass in boolean. For the third one, I'm going to pass in string. Now, whenever you type annotate that here, the array that you pass in, it cannot have anything else other than the number for this one, boolean for the second invocation, and string for the third one. Don't worry, I'm going to put these in here as well. I'm going to explain that as well. And let's call the function. It accepts an array. And for the first one, these are going to be very small, so I'm going to be closing them right here. Very good. So for the first one, I'm going to do numbers 1, 2, and 3. For this one, let's just do true and false. And for this one, I'm going to do hey, hi. Now, what happens here is, first, let's solve this. This one is going to return 3. This one is going to return false, like this. And this one is going to return hi. All right, now this is done. Let's talk about how this works. Now, whenever JavaScript sees that, TypeScript sees that, this number, now as far as the function body itself is concerned, the function definition is concerned, we don't have any type for the elements, and that's why we call it generic. Generic is not specific. It could be anything. So when I call the function in the first invocation right here, when I call the function and when I pass a number, that number is going to travel and it's going to come right here. So SumFunc, the function's type is going to be number, and then that number is going to travel right here. So effectively, when we put number instead of elements, we have an array of numbers, so we only accept numbers. So this is, I'm just going to do it like this since this is number sign, and we pass a number here as well. But keep in mind, the function's return type is going to be number as well. So the function returns a number, and there we go, the function returns a number. For Boolean, we have the same process. We pass in the Boolean here, the function accepts a Boolean. The array from generic array it's going to become an array of Boolean values. That's why when you write the generic syntax with the function invocation, you are restricting yourself. Now, in our previous challenges, we didn't do that. We had numbers, we had strings, we had Booleans. But when you specifically say that the generic type is Boolean, within that array, you cannot add anything else. So if you do true, false, and then like number 1 or like a string, then that's going to be a type error. Why? Because you have clearly said that this is an array of Booleans, and you can just add those. But if you don't want to specifically specify what is going to be the types of items within the array, then you should not do this, like our previous challenges. And then this is going to be the elements is going to be Boolean. Array is going to be an array of Booleans. And at the end of the day, what is the function going to return? The function is going to return a Boolean. And there we go. It does return a Boolean. And finally, when we pass in string, it's going to be in elements is going to become string. It's going to be an array of strings that the function accepts. And what is the function going to return? The function is going to return a string. And there we go. The function did return a string. And that's how generic functions work. So that's it for this exercise, for this challenge. See you in the next one. Hi everyone. Welcome to your first challenges solution for literal object types. For generic object types. The previous one was a literal object. The challenge statement says that we need to create a generic object type for an air conditioner with 2 properties. Now, the solution will contain winter and summer. You can come up with any kind of 2 properties that you want. And the main thing is that both of the properties can only accept 1 type, and it is a generic. So let's go ahead and let's create that. I'm going to first create the type. This is the type keyword, and the type name is going to be air conditioner. This is the type name. Let's go ahead and let's create that. So we have winter, and then we have summer. For winter, now since this is a generic, I almost forgot that, we need to pass in the generic syntax. There we go, that is a generic. Very cool. So everything is working fine. But the thing is that both of these properties, they should be able to accept only 1 type. So I'm just going to write here T and T. T could be whatever. So everything is working correctly so far. Let's go ahead and let's create the object. Const my AC, I think like this. Let's type annotate it to that air conditioner. Air conditioner type. Why do I keep doing that? Whoops. Conditioner. And I'm gonna use the black marker just to make sure it stands out. And there we go. So in here I shouldn't write T. What is happening? In here I should specify what the type is. So let's say the type is string. Cool. Let's add the generic syntax. So our air conditioner has a type of string. That means that string is going to come right here, and the winter is going to be string, and the summer is going to be string. So string is going to replace wherever we have used t. Since we have used t 3 times, string is going to replace it 3 times. So air conditioner is going to be of type string, winter string, summer string. Let me write the winter, and then summer. Winter is going to be, so our air conditioner, in winter it's going to warm us, and in summer it's going to give us cold, it's going to cold us, cool us. And I think that's it. So this is a generic object type. Are we done? Yeah, I think we're done. So see you in the next one. Hi everyone, welcome to your second challenge solution for generic object types. The challenge statement reads that we need to create a generic type for a smartphone with 3 properties. The properties that I'm going to be creating are going to be manufacturer, model, and rating. And then we need to create an object from that type and then store all the values. Keep in mind, all the values within an array. Now, the thing about this object type is that the property values, they have to be able to accept any type. So it's not like we are repeating string for all the properties. One property could be one type, the other could be the other type, third one could be any other type. So let's go ahead and let's create that. Type. This is type. Let's do smartphone. Smart. Is it one word or is it a phrase, like 2 words? I'm going to go with 1 word. Smartphone is our type. This is a generic type. So when this is a generic, and we want all the properties to have different types, not necessarily one type. I'm going to do T1, T2, and T3. This is comma. Cool. Let's close this. Now that that type is done, let's open up curly braces. We want to have manufacturer, whoops, C is there, model, and then rating. Then let's close that. The manufacturer is going to be of type T1. Then I should use the other color. So T1, T2, and T3. Now in this way, all properties, they are independent. Now type T1 could be string, number, Boolean. The same applies for T2 and T3. And they don't have to have all the same type. They could, but they don't have to. Let's create an object, and the array I'm going to do on this side of the whiteboard. Let's do const. What is the variable name? My phone. And in the example, I just saw that I've treated this as 2 words. Whatever. It is my phone. I'm going to hold it for 3 seconds, and I'm sure you can bear with me. And there we go. My phone, let's type annotate this with, just see, already brighter, thicker. Let's grab smart phone, and what shall be the types? For manufacturer, I'm going to do string. For model, I'm going to do string. For rating, I'm going to do number. So let's get the black one, string, and then number for rating. Everything is making sense, right? let me close this off first, and then let me get the object right there. So manufacturer, very simple stuff, but we need to complete it nonetheless. Manufacturer, model, and then rating. So my phone, manufacturer is Samsung. The model is J6 Plus, and rating is 3.5. And I'm being very generous. Now, since we have created our object, we should not forget the commas. We need to grab the values and store them within an array. Since I don't have any place, I could just do it right here, or I could do it up there, but I'm going to do it right there, right here. So I want to create an array. The array name is phone specs. Let's get that. Everything is very simple so far. Phone specs. Oh, there is no T. And this is an array. So we should type annotate it to an array. But what kind of an array is it? So I'm going to say that is, we could use a generic array, or we could use like a normal array, but I'm going to use a normal array. Now, when we are talking about these values, we can see that one is string, the other one is string, and then we have a number. So these are like multiple different types. We need to grab a string, we need to grab a number, and for scalability purposes, I'm just going to add Boolean here as well. And this is an array. All right. Let's create the array right here. I'm going to do my phone.manufacturer. This is very simple. My phone.manufacturer, and then comma, my phone dot model. This is L, and then another comma is going to come right here, since there isn't any space there. My phone dot rating, and feel free to check it out in the console. That is it. That is the challenges solution. See you in the next one. Perhaps we could create an entire application with simple functions. And perhaps our function could have one parameter with a very simple type. Maybe that parameter has a type of string, or a number, or a Boolean. But what if you want to have like more sophisticated functions? What if you want that parameter to be able to accept a number and a string, two different types? And in that scenario, it is going to be a little bit difficult if you don't know what type narrowing and type widening are. In this section, we're going to talk about type narrowing, and we're going to talk about type guards and type widening. Type narrowing allows us to narrow down the type of our variables. They could have 2-3 different types, but using conditionals and logical techniques, we can narrow their type down to one single type, so we can just implement that simple part of the application and then move on with the other type. TypeScript is extremely capable to do everything that I just said, and I'm going to show you all of that during these lectures for this section. Hi and welcome to this video. In this video, we are going to talk about conditional narrowing. But before actually explaining that, I would like to just explain it in the context of an example. Let's say we have a type. The type name is item, and we know that type aliases just provide names for our types. And this name type alias this item type alias is going to represent an object. The object is going to have one property, and that is going to be product name. And the type of that property is going to be a string. Now, what do we want to do? We want to create a function that accepts two different kinds of arguments. The function could accept an object like this, an item, or it could accept an array of objects. And what should the function do with that? If the object is passed into the function should return the value of that property, which is product name. But if the array is passed, the function should return the length of that array. Now, these are two very distinct things that the function has to do. And based on whether we pass in an object or an array, these two things are going to be different. Now, we know objects do not have length. And on an array, we don't have a product name property. So we need to come up with a way to actually make sure which type it is that we're tackling. Let me first create the function signature. I'm going to call it item or items. And this is going to be the function parameter is going to be item. It could accept an object or an array of these objects. And now here is where conditional narrowing is very important. Conditional narrowing allows us to narrow the type of this parameter in this specific example. The type of this parameter is either an object or an array of objects. And based on each of these two types, we are limited in doing what we want. So if it is an object, we want to get the property name. If it is an array of objects, we want to get its length. How can we come up with this logic? That's what conditional narrowing does for us. First off, conditional, we need an if statement. And secondly, we need to have some sort of a method, some sort of a tool that will help us, that would help us understand whether we're working with an array or whether we're working with a single object. On the array itself, there is a method called isArray, which returns Boolean. And if you pass in something into this array that is an array, then this is going to return true. And what I'm going to do is I'm going to pass in the parameter. And as soon as I do that, what happens is within the, let's zoom in a little bit, within the block of this if statement, the item parameter, it can only be an array. So we have successfully narrowed the item parameter's type from an object or an array of objects to just an array of objects. And we have successfully eliminated the possibility of this item being an object. Within here, within this code block, this is just what? An array of objects. It is an array. And that is what we have done successfully. So as soon as I do item dot, we can see all the array methods that are available. So what we're going to do is we want to return the item length. And outside of the if statement, what do you think that's going to be? So since we have eliminated within the if statement, we have eliminated the possibility of an object within, or I should say it like this, outside that if clause, we have eliminated the possibility of it being an array. It's like the reverse of it. So as soon as I do else, it can't be anything but an object. It has to be an object. Therefore, we have eliminated the chances of it being an array. And as soon as I do item and I do dot, we're going to see a property. Why? Because now it is an object. This is the whole idea, the whole concept behind conditional narrowing. And it is very, very, very simple. Narrowing types based on conditions or with the help of conditions. In here, if I hover on the item, we can see the item is just an array. But in here, if I hover on the item is this item. It is an object. It's very simple. I've explained it. I'm not going to explain it anymore, and I'm going to jump into the rest of the example. Now that we've done that successfully, let's go ahead and let's call this function. So what I could do is I could pass in either an object, which I'm just going to pass in product name, and I'm going to call it TS. And as soon as I do that, we should see TS, because when it is an object, we want to get the value of product name. But what about when it is an array of objects? Let me cut that, provide an array, put one object there, put another object there, and now it's going to give us the length, which is 2. All right, so to put everything in perspective, this is called conditional narrowing. It is also a type guard that we have created here. The technique is conditional narrowing, but this code that we have created here, this is a type guard. And the reason that it is called a type guard is because within the clause of the if statement, no other type other than an array can penetrate. The only type that can penetrate the if clause is going to be an array. So we are guarding our type against other types. And within the else clause, we can only have an object. And that is also another type guard. So now that you are familiar with conditional narrowing and type guards, let's move on and let's talk about object narrowing. In this lesson, I'm going to talk about object narrowing. Let's say we have this type magazine info, and within this type, we have a property of name with the type of string. We have a property of author with the type of string as well. We have a property of sales with type of number, and then a type of a property international. International. This is also going to not be a number. This is going to be a Boolean. Very cool. Price, number, and finally we are going to have publication date, which is going to be of type number as well. So far, everything is making sense. Everything is cool. Instead of publication date, I'm just going to convert it to publication year. Now I'm going to create an object from this type. And we can see within the JavaScript, we don't have this type alias. Why? Because this is strictly for compilation. This doesn't have any runtime element. I'm going to create a magazine variable with a lowercase m, and I'm going to type annotate it to magazine info. As soon as I do that, I need to provide all these properties, and I'm just going to go ahead and I'm going to provide them. Let's just replace everything with commas. The name is going to be Health Unleashed. The author is going to be Muslim Hilali. And let me provide that within quotes. The sales is going to be 1111. And it is going to be an international one. And the price, very cheap. And the year is going to be 3123. I'll publish this by that year. And we know that if we create this object and if we try to log it, magazine, as soon as I do the dot notation, I have access to all of the properties. I could get the author and it's going to show it to me. I could get whatever I want, for example, the name, Health Unleashed. Now, what object narrowing refers to is that we get the objects parts. In other words, we are only getting the parts of an object that we are interested in. For example, you want to create an object, but you don't want it to be bloated like this, like having 6 properties and having to define all of them. Perhaps you want to create an object type from this type that would only contain 1 property. How are you going to be able to do that? So what I'm going to do is I'm going to say, I'm going to create another type that is going to be magazine, but it's not going to be magazine info. It's just going to be a magazine name. So it just has 1 property with the type of string. Now, I'm going to create another variable or another object, magazine name. I'm going to type annotate it to this newly created magazine name type, and I'm going to assign to it a value of magazine object that we have up here. Now, the result is going to be something very, very interesting. First off, I need to take a look at the magazine, and I'm going to comment these two out. As soon as I do that, we can see that we have this big bloated object there. And if I take a look at the magazine name, magazine name, let's save that. We are going to get the same result, even though we have type annotated this type to only one property. So what we have successfully done is, it's not visible, but I'm going to show it to you in just a couple of seconds, is that we have narrowed this object into a smaller object, and using this object, we can only access the name property. Now, if I just copy it down below, and as soon as I do the dot notation, there is just one property. Even though we can see that entire object, but think of it like this is just read-only. You can't access it, you can't change it. And the only thing that you can access from there, that is going to be the name. You don't have access to other properties, and this is called object narrowing. Now, a cool thing is happening here is that nowhere in our code have we specified a direct relationship between the magazine name type and the magazine info type. But for some reason, it is accepting all of its values, all of its properties from this object, and it is showing it on the console. The reason that this is happening is because TypeScript has structural typing. That is why this is happening. That is why on line 28, when I assign magazine to magazine name, instead of just seeing the name, we get the structure. Now, TypeScript doesn't really care too much about the name of the types that we provide, because it is a structurally typed language. It just cares about the structure of the type. It doesn't care about that type specifically. That's why it is getting all of the info, all of the properties from the magazine object, and it is putting it in the console within our magazine name. If we take a look at the magazine name again, on line 29, we can see that it is getting all of that. Now, as opposed to other statically typed languages like Java, C++, they do have something called nominal typing. But nominal typing is not supported in TS. You might hear another term which is going to be called duck typing, which basically refers to structural typing, this paradigm that TypeScript supports. And duck typing refers to like a common phrase that is like, if something looks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck. In programming, duck typing basically means that we only care about properties we are accessing. We don't care about in this specific scenario, we don't care about the author, we don't care about the price, we don't care about the sales, we don't care about the international, we don't care about the publication year, we don't care about any of those. We just care about the author, the name of that magazine. That is why TypeScript has structural typing or duck typing, because it is just specifying that part, and it doesn't really matter for TypeScript what the name of that type is. It just takes a look at the structure. When the structures match, it puts everything right there. And even though we have all of the object right here within the magazine name, the only property that we can access from there is going to be the name. We can't say, like, for example, if I do author, we're going to get an error, and that is going to be property author does not exist on type magazine name. Even though here we do see it on line 29 that it accepts, it basically has grabbed a copy of the object, but it is sort of like an inaccessible read-only version of the object because the types, the structure of the types match. And for as long as that structure matches, you can get the type. For example, if I were to add an author here as well, which would be of type string, then I'd be able to I would be able to get that as well right here. As you can see, the error is gone because for as long as the structure matches, you can access that. That is why TypeScript is called a structural. TypeScript has structural typing as opposed to other programming languages that have nominal typing. And that is going to be it for this lecture. See you in the next one. Hi everyone, in this lesson we are going to talk about type guards. In the first lecture of this section in conditional narrowing, we saw a real example of type guards, but that wasn't the only way to create a type guard. There is actually several different ways of coming up with a type guard. And that is why I dedicated this lesson to just this concept. So without further ado, let's jump into this lesson and really understand the different types of type guards and how we can create them. Let's say we have a function and this function's job is going to be to get the product price. And this function will have a product as a parameter, which could be of type string or of type number. But the function has to return a number since we are getting the price of the object. Now, the first type guard that I'm going to talk about is going to be the type of operator. You already have a lot of experience working with type of. So I'm in the console of the browser and I'm going to say type of. And if I pass in like an empty string, this is going to give me like a type of string. Now in the console, we are strictly talking about JavaScript. In here, console of the browser, we don't have any TypeScript. This is strictly JavaScript. If I do 1, 2, 3, this is going to be a number. If I do type of true, this is going to give me a Boolean. So type of, what it does is it gives us the type of that specific variable, that value. In here, an empty string, 1, 2, 3, and true. These are values, and their type is as follows: string, number, and Boolean. Let's get rid of all of that. Now, the type of in TypeScript does the same thing. It has another function as well as, and that function is playing the role of a type query, which we're going to discuss like further in the course. But for now, just remember that type of gives you the type of a value. So I'm going to say if type of product. Now I want to narrow the type. AKA, I want to use a type guard, or I want to use a type guard. So I'm going to say if the type of the product is string, I want to do this, else I want to do something else. Now, within the realm of this if statement, if clause of this if statement, the product can only be of type string. This is a type guard. And the type guard that we are using is a type of operator. So if I do product and as soon as I do dot, we are going to see all these string methods and properties. So what I'm going to do is I want to convert this string to a number. So I'm going to say return parse int, and I'm going to pass in this product. And this is going to convert it to a number for me. Now, outside of the if statement, or the if clause of the if statement, since we have handled the string part, the product can only be of one other type. Because it can only be of two types, we have already handled string, so only number is remaining. Now in here, if I do the product parameter, and as soon as I do the dot notation, we can see we get all of the number, and here it is, number.exponent, number.toFix, number.toLocale, string, all the number properties. Now, let's go ahead and let's return the price. That's the only thing that we want to do. So this is a very, very simple type guard using a type of. Just to reiterate, in here, we are guarding our type from all other types. And the type that we're guarding is going to be of type string, and it's going to be guarded from against all other types. And so this is a type guard. We can say const course price, and I'm going to invoke the function get product price. Now I can pass in either a string or a number. So I'm going to pass in 10. Let's take a look at the course price. Course price. This is going to give me a number 10, and I could just pass in a number 10, which is just going to 9.99, which is just going to return to me 9.99. So this is the first type guard. The second type guard that I'm going to talk about is instance of. And for that, I'm going to comment out the above code. The instance of type guard gives us whether an object is an instance of a class or an object constructor. So let's go ahead. Now, instance of really has its applications when we talk about object-oriented programming. But since we have not actually arrived at that section, I'm going to give you some other kind of example that would not rely on classes per se. I'm going to create a variable, and I'm going to call it new date, and I'm going to assign to it a new date or an instance of a new date. Now, this new capital D date, this is a date constructor that creates a date for us. From this date constructor, we can create as many dates as we want. So what I'm going to do is I'm going to say if I want to check whether this new date is an instance of this date object that we have here. How can I check that? For example, you have a class and you have 20 objects spawned from that class. How are you going to check whether each of the objects is a child or is an instance, technically an instance of that class? Then here is the is instance of operator. This is just used for this kind of stuff. Now, what I'm going to do is I'm going to say, I want to find out whether new date is an instance of the date object, so I'm going to pass in the date. Now, we know it is. That's just a very simple example, so we can basically wrap our heads around this instance of. And I'm going to pass in, if it is, just give me success. If it is not, give me failure. Give me failure. Come on, buddy. Failure. And as soon as I save that, it is going to give us success. There we go. Why? Because this new date is in fact an instance of the date object. This is the second kind of type guards. The third kind of type guards is going to be specific value check. I'm going to write it here, specific value check. Now, the reason that I'm very emphasizing on this is because type guards are really, really important. Now, I think this is a little bit difficult from a readability perspective. So let me just copy that, put it there as well. And I did forget to do the same thing for the first one. This is going to be type of and number 1. Cool. So the third type guard is going to be value, specific value check. Let's say we have some value and we assign it null. We assign to this value the value of null. And then what I'm going to do is I'm going to say if some value is equal to null, do something for me. Do basically the same thing. I'm just going to copy all of that, put it right here, get rid of this brace, and just comment everything back in. Otherwise, give me failure. So since some value is, of course, the null itself, then we're going to get success. Otherwise, we would get a failure. Now, this is what's called a specific value check. We are checking something for a specific value. The fourth kind of type guards revolves around the idea of Booleans, specifically truthy and falsy values. Truthy and falsy. Truthy and falsy check. It is called truthy and falsy check. So what I'm going to do here is I'm going to say we have some value and I'm going to set it to true. I'm going to check if. Now these examples are very simple. They're just going to, their purpose is just to show you that we have these different types of check. Of course, if you just have one value, you know it is true. You don't need that check, but you can just get this concept and just enlarge it and use it within your applications. Or wherever you see that, you're going to know, okay, this is a truthy falsy check. Perhaps I should remove the and just provide a /. I'm going to say if some value is not truthy or if it is falsy, then do me this favor, show this to me. So I'm just going to pass that there, just comment that one in. Otherwise, show me failure. So as soon as I do that, we are going to get failure. Why? Because in here, we are saying that if some value is falsy, but clearly this value is truthy since it contains a true Boolean value. And now this test, this check returns failure. This is the fourth kind of type guards. The fifth kind is the kind that we have already seen, and that is going to be using some built-in method. And we have already seen that, but I'm going to give you an example anyway. Let's say we have this array of 1, 2, and 3. And then we want to check if this is actually an array. So what I'm going to do is I'm going to get the array, and I'm going to say is array, and I'm going to pass in some array. Now, if this is an array, what do I want to do? I want to console log success. Otherwise, I want to console log failure. Now, since this is an array, this is going to console log success. But in fact, if this wasn't an array, this would have been like 1, 2, 3. Then we would have seen a failure on the log. This we have already talked about extensively. And finally, the sixth type, the sixth kind of type guards is something called property presence check, which I believe we have not done yet. So I'm going to say property presence check. Everything is cool. Since we're talking about a property, we should create an object. So I'm going to say some object, and I am going to create a name property with a value of TS. Just keep everything simple. Now, I want to check if a property exists within an object. So I'm going to say if price is in, let me just provide a space, in some object, then do what for me? Then do console log success. Otherwise, do console log failure. Now, from this very simple object, we know that, well, we do have failure. I did save that. We know that basically there's just one property, and we know that that property is name. So price does not exist here. Therefore, we get failure. But imagine this would have been like a gigantic object, and you're like 100 lines below the actual object, and you're basically, or in another file, and you're calling that object, but for some reason you don't get that. So what you're going to do is you're going to provide a test, you're going to check whether or not that exists, and then you can move on with your code. And this is called property presence check. Let me pass in as price so we can see the failure. That's it for type guards. See you in the next video. Let's talk about type widening. First off, I'm going to create a variable. I'm going to call it product. I'm going to pass in TS. Later on, I'm going to get that product, and I'm going to change its value to TS. I'm going to create another variable called price, set its value to 10.99, and then I'm going to change its value to 9.99. Now, these differences, these variations, they're allowed in TypeScript. Why? Because TypeScript under the hood, when we do this kind of variable declaration, does something amazing for us, which is called type inference, which we have talked about a lot. Type inference is very, very, very convenient for us because we don't have to type annotate every little thing, and we can just tell TypeScript, okay, the control is yours, and you can just infer the type. And most of the cases, that inference is going to be perfect. So if I hover on this product, we can see that the type of this TS string has been widened to a general type of string. And the type of this word, JS, has been widened to a type of string as well. That is why TypeScript is not complaining that you're changing these two values, because their type, it has been widened. That is why it's called, that's why this lecture is called type widening. Just we are taking a look at another name for inference. In the case of a number, we can see type widening can also happen with numbers. We have one number here, and then we have another number right here. Now, type widening or type inference has its perks, don't get me wrong, but like with anything else, you need to know of its edge cases as well. So let's go ahead and let's take a look at an edge case where we need to stop TypeScript from widening the type. I'm going to get rid of all of these, and I'm going to come down here. Let's say we have a function. And the function's job is only one thing. What is that? The function's job is to give us the name of a specific product. In this case, it is going to be a course. So the function is going to give us a course name. It is going to accept a course, which is going to be an object. Cool? And then it is going to return course.name. Let's go ahead and let's create this type product. We know type aliases, they just provide names for our types. So I could just put it in line into the function signature, or I could just provide it right there, which is better for readability purposes. I'm going to create a type of product. The name is going to be of type TS. I'm going to come back to that TS since that is going to be the what we need to provide a solution for. The price is going to be of type number. Now, let's go ahead and let's call this function. I'm going to say course name, and I'm going to pass in a course object. Let's go ahead and let's create that course object, const course. I'm not going to type annotate that. I'm going to say name is going to have a value of TS, and then the price is going to be $10.99. Now there is an issue, but before jumping into the issue, what do you think? Why do you think the issue has arisen? We have an object that has a property of name and a property of price. We have a type that has a property of name and price, and we can see clearly that this function accepts this product, and this course object has the same shape as this type product. So what is the issue here? Well, the issue lies in the fact that, and you need to keep this in mind, type aliases cannot contain values. They can only contain types. So even though I have written something that looks like a string TS, this is not a string of TS. This is a type TS. Anything that comes after a colon in TypeScript is a type. It is not a value. And type aliases do not contain values. Why? It's simple. Because if they contain values, and during runtime when we get rid of them, we would effectively get rid of information that would be crucial for our application. So type aliases have to have only types. So when we remove the types, our application would not suffer in any aspect. That is why type aliases only contain values. The same goes for interfaces, which we're going to talk about later. Now, since this is a type, as soon as I hover on the name, you can see it is no longer a string. What comes after? What does come after the colon? It looks like a string. It just happens to look like a string, but this is not a string. And now if I hover on this name, you can see here it says string. So what TypeScript does for us very, very effectively, and we praise TypeScript for this, what it does for us is that it takes the value of this name property and it widens its type to a general type or a wide type of string. And that is not something we want. We want to make sure to take the control out of the hands of TypeScript and just to type annotate ourselves. So this object matches with this type. How can we do that? Where we can use the as keyword. So as soon as I do as const, now the error is gone. But before doing that, let's take a look at the error. If I take a look at the error, we're going to start at the bottom. Type string is not assignable to type TS. You can see that right here. This double quotation, TS double quote or quotation, this is in fact a type. This is not a value. That is why it says type string is not assignable to type TS. Where is the string? Here is the string. Where is TS? Here is TS. They are not compatible. So what we need to do is, first, we could do is widen the type of this name as a string as well. That would fix the issue. But let's say we want the product name to be specifically TS. We don't want it to be JS. If I do this, I could very well change it to Python. And everything would be okay. Everything would be cool. But I don't want to do that. I want the name of the product that I'm talking about to be only TS. Now, in that case, we cannot change this. We cannot widen the type because then errors may arise. So what is the other solution? The other solution is to stop TypeScript from widening the type. And we do that by using a const keyword, as const. And now if I hover on the name, we can see what does come after the name, the colon, TS. Now, this is a type of TS, this is a type of TS, and both of them are compatible. Keep in mind, here, TS is a value as well as a type. Here, in the type alias, TS is only a type. And we can take a look at that in the console as well. Log, save that, and this is going to give us TS. Now, this TS that we get in the console is a value. And this property, just to go over this one more time, this property has a type of TS, string TS, and it has the same value as well. Now, you cannot change this. You cannot just simply say this is a Python, because then you're going to get another error, which is going to say type Python is not assignable to type TS. So it is a very, very cool way of coming up with extremely restricted types for our objects. That is it for this video. See you in the next one. Now that you've had fun learning type narrowing, type guards, and type widening, it is time for you to get your hands dirty with solving challenges. Welcome to part 5 of Let's Get You Coding Challenges. In this part, we're going to talk about all the concepts that we discussed in our previous section, and there are going to be a lot of challenges. So let's get started. Hi everyone, welcome to your very first challenge solution for conditional narrowing. The challenge statement for this challenge reads that we need to write a function that handles whether a product is viewed or not. If the product is viewed once or more than that, then the function has to return true. If the product has not been viewed, it means the product count is 0, then the function has to return false. Now we know that what the function returns. It returns a Boolean, true or false. But what does the function accept? The function should only be able to accept a number or the Boolean value of true. So we're going to use a union type there. And there is something that I need to tell you, that whenever we use any kind of value for type annotations, that value is no longer considered a value. It is considered a type. And I'm going to get back to that. So let's go ahead and let's create this function and let's see how this is going to play out. I'm going to start writing the function here. I'm going to call this product view. Product view. And the parameter name, let's just say generic arg. And this is where we need to think about what the function accepts. The function accepts either a number or the Boolean value of true. Now, keep in mind that this is no longer value. This is a type. Why? Because we are using it to type annotate our parameter. And the function returns a Boolean. We know that. It returns a Boolean. Let me close that. So now that we have created the function so far, let's go ahead and let's create the function body. I'm not going to close it. We're going to close it perhaps down here. We need to think about how we are going to approach this. So we have a product, and we need to check whether it has been viewed once, viewed 0, once, or more than that. And then we need to check if the true has been passed, the function has to return true as well. So this is something that is going to be a little bit trickier for us, but we can do that. We have to break this problem into manageable pieces. Let's get started with an if statement. I'm going to say if argument is greater than 0, what is this going to return to me? Now, this is a Boolean expression. This is going to return true if the value of arg is of type number and it is greater than 0. 1, 2, 3, whatever. Then this is going to return true. And then we need to check also for when the argument is equal to true. We are going to check for that true too. So argument is equal to true. Now, in both of these cases, we want to return true from the function. Now, I'm going to explain this. This part is clear. Now, what is this? This is the logical OR operator. I'm sure you're familiar with that. The logical OR operator is going to return true if one side of this operator returns true. So it's not necessary for both sides to return true. And this logical OR operator is in the context of this if statement right here. So if the number of product views is greater than 1, we are going to return true. Or the true has been passed instead of passing the number of product views, then we are going to return true as well. But even if both of them are true, we are going to return true from the function. So this part is done. Now, we know what this is going to return from the function. That is going to be true. But there is another value in Boolean, and that is false. And we need to check if the product view is 0 or less than that. And we can do that within the else clause of this if statement. Else. And you might be asking, okay, how does else is going to check if the product view is 0 and if the product view is less than 0? Well, there is no other condition within the else. That is the only condition. Those are the only conditions that the else is going to check for. Because the function, keep in mind, we have limited what the function accepts. The function accepts a number. First, let's think about this. So the function accepts true. We have handled that. So this part is done. But what about this? We have 0, positive number, negative numbers. So positive numbers have been handled here. And what are the other cases? Negative numbers and 0. That is what the else is going to handle for us. There is no other condition. It's not like we are going to say that arg could be a string. It can't, because we have clearly said that it can either be a number or the true type. And in this condition, if the product view is 0 or it's less than that, we are going to return false. Now, that's it. The solution is done. We are done with this problem. But there is actually a shorter way of doing this. That's why I have not actually closed the function body. And that is using the ternary operator. Now, before jumping into the ternary operator, I feel like I need to explain this part a little bit better. I think we have already talked about that, but still I'm going to do that again. Let's say we have a variable const. I think we have talked about this type annotation, this variable, which is going to have a type of true. Now, whenever you're using anything, absolutely anything, where you have to use a type annotation, where you're type annotating a variable, this thing is no longer a value. This is a type. It's a type. It's a literal type. Keep that in mind. Now, this is very, very different than the Boolean true value that we have passed in right here. So this is, even though they look the same, but they're completely different. In this case, of course, they're the same because we are saying that triple equality, but imagine this one. So these two are completely different. This is a Boolean value of true. This is a type of true. Type and values, they're different. And the same thing happens here. Now, whenever you use these kind of literal types, the only thing that you can assign to this variable is the value of true. You cannot assign anything else. And I think we have already talked about this. So I thought I would clear this up. I'm going to close that. So how can we convert all these 5 lines into a ternary operator? First off, let's write. This is the short version. And I'm going to write it down below. So what I'm going to do is I'm going to start with this side. Perhaps delete it with my hand. I'm going to say return. This return is for the function. I'm going to check if the argument is true. If the argument is true, then I want to return true. How do you know this is going to return true? Because this true is going to come right here. So the return, this return keyword is going to return whatever this ternary operator evaluates to. So in this case, if the argument is true, the ternary operator evaluates to true, and this return is going to return that true. Otherwise, I'm going to return arg greater than 0. And this part might be a little bit confusing. Like you might be thinking, why this? Now, again, keep in mind, I did talk about this, that this is a Boolean expression. What does a Boolean expression produce? It produces a Boolean value. Very simple. Now, what does the function return? The function returns a Boolean value. So that makes our job easier. Now, if arg is equal to true, we return true, no questions asked. But there are 3 more conditions remaining. 1, if the number of product views is greater than 0. 2, if the number of product views is 0. 3, if the number of product views is negative, like -1, -2, for some reason. Then all of that will be handled by this. And that's why we no longer need anything else. So if the number of product views is 1, it is going to be true automatically. Because this is a Boolean expression. This thing is a Boolean expression. This is a Boolean expression. Now, if it is 1, it is going to return true because this condition holds true. If it is 0 or -1, it is going to return false. Oh, come on. Oh, that's such a mess. False. Cool. So 1 condition, 2 condition, 3 conditions. All of that will be evaluated by this. So we no longer need to create another if statement. Everything can be handled with this. So if you think about it, there are only 2 conditions. If it is a number, or if it is the true value, the type of true. That's it. So either way, if this evaluates to true or this evaluates to false, either way, that is going to come right here, and the function is going to return whichever is being produced. And let me just look at it. We have argument, type true, return true, else, false, short version, true, and yep, that's it. That is the first challenge. See you in the next one. Hi everyone, welcome to your second challenges solution for conditional narrowing. The challenge statement reads that we need to create a function that returns the first item of an array. And that function could either accept a single item or it could accept an array of any type, like a generic array. And if a single item is passed, we need to just return that single item. That's the challenge, that's it. So let's just think about it for a second. We need to have a function that can accept an array, a generic array, and or it could accept a single item. So that's a union type, we know that. But what does it return? In the case of an array, it returns the first item, but in the case that an item, just one single item has been passed, it just returns that item. So we can easily come up with that using an if statement. So let's go ahead and let's create that. I'm going to write it here. So function. What should be the function name? The function name could be anything that we want. So let me just grab the black one. I'm going to say array. Array or, this is like supposed to be capital or item. So it accepts an array or an item. And now I'm gonna, since it accepts a generic array, I'm gonna make this function a generic function. There we go. So let's type annotate that correctly. Let's use T, which we are used to. Now in here, I'm gonna write elements and I'm gonna type annotate it to an array, a generic array of T, or the single item of T. And then this function returns an item. What is that item? That item is going to be the generic item of T. Let's fix this, elements, and whoops, just clean it with my hand. All right, is that okay? Yeah. Let's move on. A check. First, since the function can only accept an array or a single item, I'm going to first check for an array. I'm going to say if array, this is the array with the capital A. There is a method on this array that is called isArray. And in here, I'm going to pass in elements. So if elements is an array, elements is an array, what do we want to do? We want to return the first item. So return elements. Now we know elements is an array. So we do what? We return the first item which has an index of 0. Now everything is cool so far. Else. Now in the else clause, the elements is no longer an array. It is a single item. So when it is a single item, what do? We return that single item. We return that single item, which in this case is elements. Right, so I think we're done. I'm not going to test it because there is no way actually to test it on a whiteboard, but we can go over the concept one more time. So we have created an array that can accept either, we have created a function that can accept an array of stuff or a single thing. And then it returns a single thing as well. Now, whenever you call this function, now before jumping into the call, we check if the elements is of type array. If this holds true, this within the block of the if statement, the elements is always going to be an array, so we return the first element. Otherwise, just close up the function. Otherwise, we know that. Otherwise, the elements is a single item. We just return that thing, even though it says elements, but this is like a single item. And whenever you want to invoke the function, keep in mind, since this is a generic function, you need to specify what kind of array you're passing. So we are saying array or item, and you need to specify here. So are you using number? You want to have an array of number, or you want to have an array of Boolean, or string, or a combination of some. Or if you don't specify that, then your array could be a heterogeneous array. It could have anything. And then you're going to pass in like an array. You either pass in an array, or you pass in, let's say, number 10, which is going to be this. So since this is a Boolean, you need to pass in a Boolean. If this is a string, you're going to pass in string. So something like this. Cool. And in here, you're going to pass in, let's say, 1, 2, and it's going to give you 1. And this is Boolean. This is not going to accept. It's going to be like squiggly, something like that. So just make sure you specify what kind of element is going to be your element. And I think that is it for this challenge. That's it. So we still have a lot of time, but let's move on to the next one. Hi everyone, welcome to the third challenge solution for conditional narrowing. The challenge statement for this specific challenge says that we need to create a function that accepts an object, an employee object. Yeah, and that object has to be created with the object type, like type alias. So the function could accept an object like a singular or a single object, or it could accept an array of objects, employee objects. And that still has to be created with that type alias. That should be created with that type alias as well. So everything is clear so far. Now, what is the return type of the function? What is the function going to return? Well, that depends on what the function accepts. If the function accepts a single object, it should return the employee name. If the function accepts an array of employee objects, it should return the length of that array. Simple enough, right? Let's jump in and let's see how we are going to solve this. I'm going to start from here. Let's do function. And what should I call this function? In here, I've said my func. Perhaps I couldn't have come up with a better name. So I'm just going to call it my func. My func. And we have the parameter. The parameter, in the solution, I've written employee or employees, very long. I'm going to say, you know what, I'm just going to do that. Employee or employees. Employees. Let's type annotate this. This is where it is important. And I just remembered we did not create the type. I'm going to create that. So it's going to accept an employee object. So I'm going to say an employee type. Keep in mind, this is a type we are yet to create. So it either accepts one single employee type or an array of employee types. So when I do employee and I give it the array syntax, this is an array of employee types. This is a single employee type. This is an array of them, since we are specifically saying that. All right, everything is cool so far. Okay. Now, what is the function going to return? The function is going to return the length, or the function is going to return the name. So I'm not going to give the function a specific return type. I'm going to let that be inferred. Let's create the function body. Now, before jumping into the function body, I'm going to create the type. I could create it right here. So all the way to here. I think I can create it there. So we have type. What is the type name? Type name is employee. Why shouldn't I write it with the red one? Employee. And it only has one property. That property is of type, name. And the property name is name, and the property type is going to be string. Cool. So that is cool. I think I didn't mention this, that the object has only one property, and that property is of type, the name is name and the type is string. So now that, I think you can see that, right? You can see type employee. All right, let's jump into the function body. Still have time. First, we need to check whichever it is. Now, from our previous encounter with arrays and the isArray function or method available on the mother array, we know that we can check for an array faster than we can check for an object. So let's just go ahead and let's check for an array. I'm going to say if, let's get the mother array that produces all the arrays. And then I'm going to say dot is array. And then I'm going to pass in this. If employee or employees is an array, just should have written this shorter. Or, employees. If this employee or employees. If this is an array, we want to return its length. So this is for the F. I'm going to say return. Oh my goodness, I have to write that again. Shouldn't I? Yeah. Let's do that. A little faster. Or employees length. So I'm going to do dot. Let's do that with blue so it is distinguishable. There we go. So we return the length. So now this is an array. We return the length. We get out of here. We say else. Otherwise, what is that going to be? This is going to be an object. So we can just say, oh my goodness, I have to write that again. Oh, I thought, okay, I'm not going to write that much. Anyway, employee or, oh goodness, employees. There we go. So dot name, right? That is going to give us what do we want? Dot name. This is the if statement. This is the function. Are we done here? I think so. So that's it. That is it. So we created a function. We created a function that is going to return if the array of objects has been passed, an array of objects, it's going to return the length. If only one object is passed, it's just going to return the name. Of course, you can always go ahead and you can check that within the console of the browser or using your VS Code. That's it. See you in the next one. Hi everyone. Welcome to the solution of the object narrowing challenge. The challenge statement says that we need to create an employee type that has a property of name with the type of string, position title, string, age number, and then hire true. And then we need to create an object instance from this type. And after we have done that, we need to create another type narrowed only to the employee name. Let's go ahead and let's see how we can do that. First off, let's create our type. Okay, I can do it here. This time I can. The type is going to be employee, right? It is going to be of type employee. Let's create this type. I'm going to have name, position title, age, and hired. Name, position title, position title, name, position title, what was the other one? Age and hired. Why do I keep forgetting that? Age and hired. You can close the type there. The type for name is going to be of type string, position title string, age number, and hired boolean. Let's create an object from this. I'm going to do const I'm sure you can read that. New hiring. Let's type annotated to employee, and we can see that all the properties are required. Therefore, we need to pass in all the properties. We have name, we have position title, and in case you have forgotten my face, here it is. We have age, and there we go, we have hired. So let me close that there. What should be the name? The name that I've written here is Bill. Position title, junior, developer. Age is 24. Hired is true. All right. So far everything is okay. Now we need to create another type that is going to be narrowed to only the name of the employee. And maybe one there. So let's create another type narrowed to the name of the employee. Imagine there is like a wall here. So I'm not going to do anything. Type employee name. I'm going to name this employee name. Not the green one, the red one. Employee name. So this is the type, and it's just going to have one property since we just want to get the name of the employee. And it's going to have name, and the type of name is going to be of type string. So this is our type. Now we need to narrow this object. We need to do what? We need to narrow this object. So how can we narrow the object? I am going to create another variable. Let's do const employee name. I'm going to type annotate this to the new object that I've created. Employee name. Is it too light, too faded out? Just bear with me for 3 seconds, and there we go. Cool. It is employee name, and I'm going to assign to it new hiring. Whoops. Where is the E? I guess this could be the E, and this could be the W. New hiring. Cool. And if you do console log employee name, if you log that, how can I do it? I'm just going to write it here, console log employee name. employee name. You're going to see the entire object. This is going to be the new hiring object right here. Object, entire new hiring object. But if you do the console log employee name dot name, this is going to give you the name, which is going to be Bill. So this is going to give you Bill. And now let's go over this. So everything is fine. I don't think, whoops. Let me put everything there. Okay. So we did create this type, and we type annotate this object with this type, and this type is done. It's done. We created, what happened here? All right, so we created this object, new hiring name, position title, age, and hired. And then we created a narrower type than the employee itself. We said that this is employee name. There we go. We assign that to our variable of employee name. And now when we take a look at the value for employee name, that is the new hiring object. Why? Because that is what we have assigned to it. That is going to be the new hiring object. So if you take a look at that, that is going to be the entire object. But if you do console.log name, it's going to give you Bill. And if you do like employee name dot age, it's going to throw an error. Why? Because it's going to say that age doesn't exist in employee name. And this is called object narrowing. Why? Because we have selected like a bigger object, and we have narrowed it down to a smaller one right here. At no point in time, this object knows that this exists, nor this knows this exists. They have no connection. So I could say like this. I could do it like this. These two types, a little bit better perhaps. These two types have no idea. Why two? Maybe just one was enough. They have no idea the other one exists. And that is the cool idea with object narrowing. No one knows. This doesn't know this exists. This doesn't know this exists. Even though this is a part of it, it doesn't know that the object exists. The cool thing is that we can create a narrower object of any type. It could be name string, it could be position title, age, hired, it could be anything. So you can have like an object that has 1,000 properties, and you can select 5 that you are interested in, and you can start using them. All the while, your objects are safe. Even though you're going to see the object within the employee name, you're not going to be able to access any of the other properties. So you can't access position title, nor age, nor hired. Because this type doesn't know that this type exists. It doesn't know it. It can see it, but it can't access it. So when it can't access it, it can't modify it. Therefore, a type-safe system. See you in the next challenge. If I asked you, what do you think how important objects are in JavaScript? What would your answer be? Perhaps on the lines of really, really important. Perhaps the language wouldn't be the language without objects, right? And that is the case with TypeScript as well. We have already talked about one way of creating custom shapes for our objects. However, we ended up with a lot of flexibility. We ended up with being able to create a shape for our arrays, for our variable declarations, among other things. But what if there was a way to just create shapes for an object? I mean, you would think a programming language that is a superset of JavaScript would have thought of that. And you're right. They have, or it has, whatever the case is. So in this section, we're going to talk about interfaces. Interfaces are used to create shapes for an object. Very simple. And they are the go-to resource, the go-to technique that you can use in order to create the shape for any kind of objects as well. Now, since they're working with objects, you might be thinking, okay, so they're working with objects. What about class instances? You're right, they're going to work with class instances as well. We are going to talk about that further in our course. For now, I'm just going to get you started with interfaces, how you can create interfaces, add methods, how you can extend interfaces, how you can augment them, and finally, generic interfaces. See you inside the section. Hi everyone. In this lesson, we are going to talk about the interface type. An interface is basically a special type that allows us to create a blueprint for an object or an instance of a class. Let's go ahead and let's first create a type alias of employee with the name employee. And in here, what I'm going to do is I'm going to provide a read-only ID, which is going to be of type string. I'm going to provide a name, which is going to be of type, this is going to be of type number, sorry for that. And then we are going to have hobbies, which is going to be an array of a string array, basically. Now, we have already talked about type aliases and how one of their use cases is to provide a shape, to provide the shape for an object or a blueprint for an object. But interfaces do that as well. Now, how would we convert this type into an interface? I'm going to copy that, put it down below. The first thing that I would do is I would have to get rid of the type keyword, and I'm going to pass in the interface keyword. And the second thing that I have to do is interfaces do not contain the equal sign. I have to get rid of it. And now everything is cool. There is an error because we do have a type by this name, duplicate identifier. So I need to go ahead and I need to comment that one out. Here is your very first interface. Congratulations. Let's move on. But before moving on, you might have this question in mind. What is the difference between a type and an interface, a type alias and interface? I've spent so much time learning type aliases, and now I have to learn something new that basically does the same thing. Well, a type alias has a little bit more capabilities than an interface. An interface can only provide the type for an object. That object could be an object literal, or it could be an instance of a class. But type aliases, on the other hand, they could provide types for anything. For example, type alias could be like just say name and just provide it with the type of string. You could say type price and provide it with type number. Now, these kind of things you cannot do with an interface. Why? Because an interface is solely developed to create the shape for an object. And that is it. That is the whole extent of it. But a type alias could create the type for an array, an object, a number, a price, and anything could be created with a type alias. But interfaces just deal with objects. That is the main difference that you need to keep in mind. So how are we going to create an object from this interface? Now, what I'm going to do first is let's go ahead and let's create a function that would give us all this employee information. So I'm going to say function get employee info. And what I'm going to do is I'm going to pass an ID, which is going to be of type number. I'm going to pass in a name, which is going to be of type string. And I'm going to pass in hobbies, which is going to be an array of strings. And what do I want to get at the end? I want to get something that has the shape of my employee interface. Keep in mind, the rest of the code is commented out, so the employee only refers to this interface. I'm just going to provide a comment there so we know that we're what we are working with. Since I do have that, this is what the function is going to return, this employee object. And we need to basically use that as well. Now, what I want to do is I have to return an object. Now, that object has an ID. The ID is going to be this ID parameter, which I'm just going to paste in right there. And the yellow squiggly is gone. And then the object is going to have a name equal to the name parameter of the function. And now the other yellow squiggly is gone. And finally, the object is going to have hobbies, which is going to be this hobbies that we pass in right here. And now all these squigglies are gone. Of course, we can't see anything on the console because we haven't done anything yet. Let me just do that. Everything looks awesome. So we have a little bit more room here. Now let's create an object and let's pass it to this function. I'm going to say let employee. We could type annotate it to the employee interface, and I'm going to create. You know what? I'm just going to do a literal object type. Just pass it directly into the object. I'm going to say get employee info, and in here I need to pass in an object. Not an object, I need to pass in an ID, which is going to be 1. In name, which I'm going to pass in as Glenn, and an array of strings, which are going to be hobbies, reading, and walking, the cliche hobbies. All right, and there we go. Everything looks awesome. We can take a look at that in the console as well. Employee. And this is going to show it to us. Come on, buddy. I think I have not changed the index. All right, I need to add the script right here, source 2.js. Let's save that. And now we see our object. Everything is looking awesome. So this is an object. Let's go over let's hover on this function. We can see we have an ID, type number, name type string, hobby string of an array of strings, and this function returns an employee object, an employee interface, and as soon as we pass this here, since it satisfies the return type of the function, everything is okay. And if we take a look at the employee variable, it has a type annotation of employee as well. And I think that is it. Well, there is one more thing that I need to talk about as well. That is going to be, again, that is going to be revolving around the idea of interfaces and type aliases. Now, type aliases do have more applications, like you could use them to type annotate anything, to create a name for any kind of type annotation, which is a better interpretation of type aliases. But interfaces have more. You can do more with interfaces. They have more functionality. And we're going to see that throughout this section. So let's jump into our next lecture and let's talk about interface methods. Hi everyone. In this lesson, we're going to talk about how to add methods to an interface. We do have this interface right here. This is from our previous lecture. And what I'm going to do is I'm going to add a method called employee hobbies. The job of this method is to give us all the employee hobbies, basically show it to us. And the way that we are going to provide a method to an interface is like this. We provide the name, provide the parentheses, and then we should specify the return type of that function or that method. And in this case, this is going to give us an array of strings. Let's save that. As soon as I do that, since we have changed the shape of this interface, there is an error in our function. If I hover on the error, it says right here, it says that basically the employee hobbies is missing in this type, but it is required in the type employee, which is the interface. So we are missing that, and we need to provide it. Now, before talking about that, what I'm going to do is I'm going to get rid of this function return type, which is employee. Let's get rid of it. And as soon as I do that, we can see that the error is gone from there, and it is right here. It says the same thing, that employee hobbies is missing. We are going to come back to this error, but first we need to talk about this function body, this function definition. Now, within the function definition, what we have is an ID, a name, and a hobbies. And what we are returning is we have the same name for key and we have the same name for the value. So we could just shorten this to ID, which would infer that the key and the name have the same, the key and the value have the same name. We could do it like this, and that would be fine. And I'm going to get rid of the second comma. So this is like a little bit more readable. Now, since the function doesn't know what its return type is, it just throws at us this return type, this generic return type, like an ID of type number, not generic like literally programming generic, but speech generic. ID number, name string, hobbies string. What we could do is we could assert the type of this object that this function returns. We could say as, and in here I'm going to say as employee. And as soon as I do that, if I take a look at this object, we can see that now it can accept the type as employee, and all the errors are gone. If I take a look at that, we can see we have the hobbies, we have the ID, we have the name. But what happened to this method? Well, when you assert the type of something, you basically take the type safety out of the hands of TypeScript, and you are basically bound by your typecasting, and that is why it is you have to assert the type very cautiously. And if you know exactly what the type is, and for some reason TypeScript doesn't know it, and you know all the ups and downs and all the edge cases of that typecasting or type assertion, then that is going to be like one of the examples or one of the use cases of a type assertion. But in this specific case, we can see that there is no error. We have lost a piece of our information, and we don't know where that is because we have taken that type safety out of the hand of TypeScript before clearly or completely understanding what the shape of the object is going to be like. So in this specific example, I'm going to get rid of the as keyword. I am going to annotate the return type of this function to that interface, so we end up with that error so we can fix it. All right. Now in here, what I'm going to do is I'm going to create an employee hobbies method. Now the job of this method is to do only one thing, return the hobbies. So I'm going to say return. I'm going to access the parameter, which is employee, and I'm going to do the dot notation. And as soon as I do the dot notation, we can see hobbies right here. And now if I save that, we can see the function right here as well. Now, how are we going to be able to use this function? As I'm going to come down here and I'm going to say log employee dot employee hobbies, and let's invoke the function as well. And this is going to give us an array of reading and walking. Now, this employee.hobbies, you could achieve it this way as well. But if you're familiar with the this keyword, you don't need to pass an employee. You can just, instead of that, you're going to say this, and the this keyword would refer to this current object. And that would work fine as well. But don't worry if you're not familiar with this thing right here, which is the this keyword. I am going to talk about that in our object-oriented section a lot. So I'm going to revert it back just for those of you who are familiar with the this keyword. You can go about it that way as well. And I think that is everything that I wanted to talk about. Let me just take a look at that. There we go. That's it. See you in the next video. Hi everyone, let's talk about extending interfaces. Extending interfaces allow us to extend one interface into another. So we can access the properties of one interface into another interface. Now, this is the example from our previous lectures, and we have this interface employee. What if, for some reason, we want to have an interface of a department that would contain all the departments in our company? We want to create a specific interface for a department. We want to create a specific interface for everything that we have in our department. For example, in our company, like department, like products, like discounts, whatever. And we want to separate all of these interfaces from one another, but we want them to be connected at the same time. So how can we do that? First off, let's go ahead and let's create this interfaces property, which is going to be department. It will contain an array that will contain strings. And since I've added that there, I'm going to add it right here as well. I could say after the name, I'm going to say department. And as soon as I do that, there is going to be an error. And if I take a look at the error, if I come down here, it says no value exists in scope for the shorthand property department. Either declare one or provide an initializer. Well, that was vague. Let's take a look at this error. That says object literal may only specify known properties and department does not exist in type employee. All right, now that gives us a little bit more clue. This department property does not exist in type employee. So how can we do that? How can we fix this issue? Now, if we think about this, we want our employees to be subject to departments. So it is safe to say that we want our employee to extend the department interface. And as soon as I do that, now if I take a look at that, there is a different kind of error. And it's that error that basically says there is no initializer. We need to provide an initializer for this. And the reason that it gives us this error is because we have not actually specified that in the group of parameters that we have here. So before the hobbies, what I'm going to do is I'm going to say department, and this is going to be an array of strings. And as soon as I do that, let's add a comma, everything is going to be fixed. But now there is another error. Why? Because we have 4 parameters and we have passed in only 3 arguments. And there we go. It says expected 4 arguments, but we have got 3. So where should we provide it? We have an ID, we have a name, and we have a department. So after the name, I'm going to create an array. And within this array, I'm just going to provide one department, which is going to be development. Let's provide the comma. And now everything is okay. Get rid of that as well. There we go. So we have department, which is development. We have this method, employee hobbies, we have ID, and we have name. So we have successfully extended this interface, the interface of department with the interface of employee. So the employee is a part of the department. Any property or method that the department interface has or we would create in the future, that would automatically be copied within this employee as well, within this employee interface. That is it for extending interfaces. See you in the next one. Hi everyone, in this lesson I'm going to talk about augmenting interfaces. When creating an interface, we can have 2 interfaces with the same name. Let's take a look at that. Interface, let's say we have, why do I have this open right here? I should have the JavaScript version. Let me just take a look at that. There we go. I'm going to create an interface that is going to be products or product. And this interface would be very simple. A name with a type of string and a price with the type of number. Let's say down below in our code, we forgot that we have this product interface and we end up creating another product interface. Well, in this case, it is allowed, but this is not allowed if we talk about type aliases. So if I have one type alias, for example, by the name of name, and if I set it to string, I cannot have another type alias with the same name, because in that case, we're going to have this duplicate identifier. So 2 type aliases cannot have one name, but 2 interfaces can have one name. That is why it's called augmenting interfaces or interface merging. Within here, what I'm going to do is I'm going to pass in rating, which is going to be of type number, and I'm going to pass in sales, which is going to be of type number as well. So everything is working fine. What happens if we try to create an object from this interface? well, we would see what we expect. And you can see as far as we created these interfaces, we didn't see anything in the JavaScript world. Why? Because these are like types. They're just types, and they're not going to be converted into anything relating runtime. They're going to be compiled away. So in here, as soon as I do that, now what do you think would happen? I would perhaps try to specify the name, which would be TS, the price, which would be not number, 10.99. But you might think that that would be the end, but no. This is why it's called interface merging. When we have two interfaces with the same name, the second interface merges into the first one. Therefore, it augments or enhances the capabilities of the first interface. The first interface had only two properties, but we have augmented it with two more properties as well. And we're not using any kind of extents. You can see that? This is like augmenting interfaces. And now we need to provide a rating of, I don't know, like 4.6 and the sales of 1111, hopefully. And now here we have our object. So the object type annotated to the interface, one interface, actually two interfaces with one name, it has to contain all the properties. But this is not where the cool stuff ends. If I just copy that and comment everything out, because I'm going to show you something else, let's just come down here. Let's paste it there. Before actually showing you that thing, you might be wondering, what happens if in our second interface we have a property with the same name? Well, that will be allowed only in one condition. If I'm going to get the price. If the repetitive property has the same type as the first instance of that property. So if it is of type number, it is going to be fine. As you can see, there is no error. But if that property has a different type, for example, string, then there is going to be an issue. Why? Because we have this property of price, and what we want to do is, here it is, type number. We want to assign to it a type of string. So type string is not going to be able to be assigned to type number. So here it is, subsequent property declarations, subsequent, keep that in mind. Property declarations must have the same type. Property price, come on buddy, must be of type number, but here it has type string. And then it shows you where that price was actually declared. It was declared right here. So that is something that you need to keep in mind as well. Now that we are done with this little edge case or dilemma, let's jump into the actual fun thing that happens when you augment an interface. Now, I'm going to get rid of this. Let's just save that. What I'm going to do is I'm going to get this constant, this object, this variable, and I'm going to put it right here. And I'm going to save that, and everything is working fine. And you might be thinking, all right, what is happening here? Well, what is happening here is that we are creating an object with two properties, and these two properties, as far as the object itself is concerned, they have not been created. Why? Why can we do this? The reason that we can do this is because of that augmentation. When we augment an interface, all these properties, they migrate to the original interface. Now keep in mind, even though these two interfaces look the same, and when it comes to their name, they have the same name, but there is actually a hierarchy at place here. That hierarchy specifies whichever name comes first, that is the main interface. Whichever name comes last, that is going to be the sub interface. So the main interface in our equation is this product. And this one, the second copy of it, is actually a part of the first one. So it doesn't matter how many lines below the object you augment an interface, that object is going to immediately reflect the changes. And this is something that you need to keep in mind. Let's say you don't have this, so I'm going to cut that. You know that you have an interface. I'm going to cut this one as well. You know, oh, whoops, let me just cut it again. So you have this product interface and you have created an object, and then you come way below here and you create an interface of, since I've done two cuts, I'm not going to be able to just paste that. Let me just fix that. This one I'm going to delete, save that. So in here, there we go. We have this interface. Now, I have created another interface, and perhaps I'm not sure if I have this interface or not. But there is an error. If I take a look at the error, it says type name string price number is missing the following properties from type product. What are the properties? It is rating and it is sales. Well, where is that coming from? It is coming from line 45, column 7. Let's go back to line 45, column 7. Here it is. And you might be thinking, all right, I have this interface, and perhaps these two interfaces, they're really apart. Like maybe like there is like one in another file. And you're going to be thinking to yourself that, well, this doesn't make sense. If you don't know augmentation, interface augmentation, this is going to confuse you a lot. But if you do know that, and you have watched my course, and you know that it happens, you know immediately, oh, it happens. Why? Because there is another interface with the same name. And I need to fix that. Either add these properties, or just remove that interface, or just give it another name. For example, product 1. Maybe this is product 1 and this is product 2, and you just want to get the product 1, and you can now safely remove these, and now that merging is not going to happen. So now you know everything there is to know interface merging or augmenting interfaces. See you in the next video. Hi everyone, let's talk about generic interfaces. We have already talked about so many different cases of generics, and when it comes to interfaces, the idea is the same. Through generics, we can create interfaces that can relate to several different types. Let's create our very first interface, which is generic, and I'm going to call this product, and we're going to use our angle bracket, which is the generic syntax, and we know that the generic letter that we use is T. This is like a common convention that you're going to see in other people's code. And it is best to basically follow these conventions. They're going to make your life a lot easier. And here, what I'm going to do is I want to create a price property that would have this type T. I do have an error. All declarations of product must have identical type parameters. Augmenting. Yep, I knew that. Didn't I comment? Oh, I didn't. So let me comment these ones out as well. Save that, and there we go. So now we have an interface of product with a price that could be of type anything. Let's create an object from this. I'm going to say product 1, type annotated to interface. Now, we have talked about generic types, and generic interfaces act in the same way, but without the equal sign. So we have created a type parameter, which is this T. And for every parameter, we know that we need to pass in an argument. What is going to be the type argument? In this case, I'm going to say that the type argument is string. So if I say price, I can only say like $10.99. Let's take a look at another example of this object. I'm going to call this product number 2. And this time for that type parameter of T, I'm going to pass in a number, an argument of type number. Now I can say 10.99. So it could be anything. This could be a string, it could be a number, and that is why it's called generic, because it is not specific. This is one example. Let's take a look at another example. In this one, what I'm going to do is I'm going to provide more than one type parameter in the parameter list, type parameter list. We have this product. Let's say we want to get diverse T1, T2, and T3. And I have a name, which is going to be type T1, a price, which is going to be type T2, and availability, is that correct? It's going to be T3. Let's create an object, const course product. So again, we have 3 type parameters, 3 type arguments. For the first one, I'm going to pass in string. For the second one, I'm going to pass in number. And for the third one, I'm going to pass in Boolean. And now name will be TS. Price will be 10.99. And availability will be true. That is it for generic interfaces. See you in the next one. I hope you're enjoying the challenges so far, because I've got some more for you. In the previous section, we talked about interfaces, and in this section, we are going to solve some challenges together. Let's get started. Hi everyone, welcome to your first challenges solution for interfaces. The challenge statement says that we need to create a product interface with 3 properties: ID, name, and category. And then we need to create a function that extracts all these property name values, and the return type of the function should be this specific interface. Let's go ahead and let's see how we can do that. And keep in mind that the function has to return an object. It returns an object. Let's go ahead and let's see how we can complete this challenge. First off, I'm going to create a product interface. So we have interface. Since this is in fact a type, I'm going to use the red marker, product. And now we are going to have 3 properties. We're going to have an ID with the type of number. We're going to have a name, string, and a category of type string as well. Now ID, what I could do is I could make it read only, if you can read this, read only. All right, and this is going to be type number, string, and string. All right. That part is done. Let's create our function. ID, name, and category. There we go. I'm going to create a function right here. The function name is going to be get product info. Get product info. And it's going to get the product info for us. I hope I can fit it in here. There isn't a lot of space. Perhaps I could have written it down there. Anyway, we have an ID with a type of number. So I'm going to provide little space. We have a name with a type of string right here. And we have category with type of string. And I'm going to close the function here. This is going to be the function body. Cool. This is going to be number, string, and keep in mind that this function's return type is the product interface. So this product interface that we have created, that is what the return type, I hope you can see that, that is what the return type of the function is. Right? I always not utilize the space. So you can see there is this space, and then I've come down here. Anyway, so we want to return all the we want to return an object with that course, with that product that we have created. So I could say return. I want to return an object. Since this is an interface, our object must be exactly like this. So for ID of this is the parameter ID. I'm going to get the ID there. Cool. And then for the name that I've passed in here, keep in mind this first one is the parameter. The second one is the object key. Name. And third, we have category. I'm going to write it like this, but then I'm going to shorten this as well. Category. So everything is making sense so far. Now in modern JavaScript, what we can do is we can go ahead. If the key and the value, they have the same name, we can just get rid of all the values. And a key of ID would imply that the value is ID. That's exactly what it would imply. So we don't need to write key values. If they are both the same, we can just remove one and just keep the other. All right, so now that this is done, the only thing remaining would be for us to invoke the function. So I'm going to say let product, and I'm going to invoke the function. Before doing that, let's type annotate this with the product. Not that we need to, but still. This is the product interface. And in here, I'm going to call the function get product info. So for the ID, I'm going to pass in, I seem to have passed in 1. For the product, I'm going to pass in, how is that spelled? Yeah. QWIK. This is a new JavaScript framework. Quick. And the category is going to be technology or program or web frameworks, whatever. So that's it. That's basically the statement. We created an interface with 3 properties, and then we should use this interface in a function, type annotated with that interface, and return an object. And there we go, we just returned this object. So if you log this, you're going to see something, an object like that in the console. That's it. That's it for this challenge. See you in the next one. Hi everyone, welcome to the second challenge solution for interfaces. The challenge statement for this challenge reads, what is going to be the value of the dog name? So let's go ahead and let's see first what we are working with. We have a type of cat. It's a type. And then it has one property of type string. Then we have a type of an interface of dog. So it's an interface. We had a type there. And it has the same property with the same type annotation. I have created an object from the cat type, and the variable name is cat. It has a name. The name value is George. And then I have assigned that to the dog variable with the dog interface, type annotated with the dog interface. Now this annotation, first we need to talk about this. So on this side, we have an object that has a key of name with the type of string. That's cool. And on this side, I could just write it here. We have name string. And on this side, we also have something like name with type of string. So their types match. That is cool. So when the types match, dog.name is going to be dog.name is going to be George. George. Since the types match, we have assigned the object of cat to the object of dog. And when I say dog.name, since there is only one property, when I do dot, it's gonna show me name. And when I access the name, it's going to be George. That's it. That's it for this interface, for this challenge. See you in the next one. Hi everyone, welcome to the third challenge solution for interfaces. The statement for this challenge says that we need to create an interface of product name, and then we need to create an interface of product price that extends the product name interface. And finally, create an object from that interface. Let's see how we can create that. First, and interface. This is T inner. Come on. We have an interface. This is going to be product name. Can I fit that there? Let's just add it there. And I'm going to add a name there. Then we have another interface. Interface product price that extends the product name, and it has a price of type number. I'm just leaving out the annotation so I don't have to like do a lot of closing, opening and closing of caps. Product name, barely fit there. This is going to be product price, extends product name, product name. There we go. The type of this is string. Type of this is number. Cool. Let's create an object from this. What should be the object's name? It is product, and it has to have the name and the string within it. So what I'm going to do is I'm going to say const product. We are going to talk about what the type annotation is going to be. And then right here, we're going to have name of the product and then price of the product. There we go. So first off, the name of the product is going to be TS Bootcamp C, and the price is going to be $10.99. So if I do the type of this, if I type annotated to product name, then it's not going to work because product name only has one thing. It has a property of name. So what I have to do is I have to take a look at the product price. The product price extends product name. Therefore, product price has the property of price as well as the property of name because it extends it. So it inherits that. Product price. And that's it. That's it for this challenge. See you in the next one. Hi everyone. Welcome to the fourth challenge solution for interfaces. The first thing that I would like to do is, I just remembered I didn't change this from 3 to 4. Just change it to 4. And we already have some stuff on the whiteboard, and I thought, okay, it's technically the same thing with just one minor change. The challenge statement for this one says that we need to create a type of product name. So let's convert this to a type. How can we do that? We're just going to write type. But there is something else missing here as well, and that is the equality sign. There we go. So create a type of product name and an interface of product price extending the product name, and then create an object from that. And then when we type annotate it, we type annotate the product with the product price, which is going to be name bootcamp, and price is going to be $10.99. And that's it. That is the challenge's solution. See you in the next one. Hi and welcome to this section. In this section, we're going to talk about more intermediate TypeScript types. Now, these types are really, really important, and I really hope that during the previous sections, you have had a lot of fun. We talked about a lot of concepts, and we also together solved a lot of challenges. And that is why all of those were really important in understanding all of these concepts. We're going to start talking about the unknown types, index signatures, indexed access types, Now, all these types are really, really important if you were to understand how object-oriented programming works in TypeScript, how type queries, map types, utility types, how all of these come together and they form the documentation of TypeScript, they form the source code of TypeScript, and they basically make TypeScript what it is. By the end of this section, I'm going to talk about two really newer concepts in JavaScript, and we are going to take a look at their implementation in TypeScript as well.
Hi everyone, in this lesson we are going to talk about the unknown type. Since the unknown type is a little bit trickier than other types, trickier to understand, I'm going to go over an example, then we are going to jump into the actual code. For example, let's say we have created a library, much like Swiper.js, and we have actually deployed it, and developers are actually using it. And the consumers of our library, they might not use TypeScript all the time. When they're not using TypeScript, they're using JavaScript, and JavaScript is a value-based language. There is no type. And they are bound to pass in something somewhere that we actually don't require it. We don't expect it. For example, somewhere we might require a number, they might pass in a string. Somewhere we might require a string, they might pass in a number. So we are left with this some sort of type that we have not actually tackled yet because we haven't studied the unknown type. And a common intuition would be to assign it to value of any, to a type of any, sorry. Now the type of any is extremely flexible, so we could assign it any value that we want, and effectively as soon as we do that we lose everything that TypeScript has to offer us. And since we are creating that library, we are authoring it, we need a little bit more control over that type. That is one of the use cases of the unknown type. I'm going to start with very simple examples, and then we're going to build on those examples and on those concepts. The unknown type is created so we first find out what the type of data received is, and then using some sort of narrowing we find out what the exact type is, and then we do whatever we wanted to do initially. The unknown type can be assigned to any value, and in this sense it is almost like the any type that we have covered before, but they're generally different, and I'm going to talk about that in this lecture as well. Let's say I have a string, some str, and I type annotate it to unknown. Since this is a type, it comes after the colon, and I'm going to assign to it a value of hey. Now, we could assign a string to the type unknown, or we could assign a number to the type unknown. This is unknown, and I could just say like 25% is that. So unknown could accept a string, unknown could accept a number. However, we cannot use unknown where TypeScript requires a number or a string type. For example, if I say let other num, I'm going to type annotated as number, and then I'm going to pass in discount. As soon as I do that, it's not going to be accepted because type unknown is not assignable to type number. All right. So far everything is clear. I'm moving a little bit slowly, so I just want to make sure that you really understand. So far, I have not shown you a real use for the unknown type. The unknown type is only useful if we narrow it to a more understandable type. So essentially what we're trying to do is we're trying to avoid a runtime error and potentially replace it with a compilation error. Now the narrowing that I'm going to be using here is going to be using a default value. So I'm going to say, let's say we have a discount and we don't know the type for it, and there is a value of 25. I'm going to create a variable and I'm going to call it other num, and I'm going to assign to I'm going to type annotate it to number. Now the way that I'm going to go about this is that I'm going to say if the type of discount is equal to number, which in our case it is, then just pass and discount. Otherwise, I'm going to use a default value. That default value is going to be 10. Let's log this. I'm going to say other num. Now, since 25 happens to be of type number, if I save that, we are going to see that in the log. But if 25 was a string, for example, in this case, 25 is a string, then we would fall back to a default value. All right. Now, let's talk about the any type. In the case of the any type, we know that the compiler creates a type that for most cases it is incorrect. However, with the unknown type, the compiler forces us to narrow the type and produce a correct error if the types do not match. All right, so let's go ahead and let's take a look at the any type. And what I'm going to do is I'm just going to create another comment right here. And now let's talk about the any type. Let's say I have a variable course name and I'm going to type annotate it to any. Now this variable could be anything. Let's say I'm going to pass in TS. Let's create another variable course price, and we know that the course price is a number. However, I can assign to it course name because of the any type, and this is going to work even though this is a problem, this is a bug. This is going to work perfectly fine. We have successfully stored a string inside a variable with the type of number. But type unknown allows us to actually catch these kind of errors. Let's go ahead and let's take a look at another example. I'm going to comment this one out. This was just a brief overview of any. Let's say we have our variable course name, and I'm going to type annotate it to any. I'm going to pass in TS, and then I have a course price. Type annotate this one to unknown, and then I'm going to assign to it a value of course name. Now, the thing that you need to know, the first thing with any and unknown is that they are assignable to one another. So you could assign a value of type any to unknown, and you can do the vice versa as well. So I could just copy that. Let me comment this one out. Put that here. I could change this with unknown, and I could change this with any. And in both cases, it is going to work. Why? Because in both cases, fundamentally, we don't know the type. In one case, it's extremely flexible. In the other case, it's extremely inflexible. But in both cases, we don't know the type. That is why they are assignable to one another. Now, this brings us to another danger zone in TypeScript when we're dealing with the type any. We know that as soon as we use type any to type annotate a variable, we lose type safety, which is not what we want. TypeScript cannot know the type when we are using the type any. I'm going to get our the same example as before. I'm going to type annotate this to unknown, and I'm going to assign to it a value of TS. And then I'm going to get a variable course price. I'm going to assign this to a type of any, and let's give it a type annotated any. It's not assigning type annotation, and then we assign it a value of course name. Now, what we could do is we could say we have a variable of price with a type of number, and I could pass in price here, and everything is going to work. Now, if we do this the other way around, it's not going to work. Let me log this so you can really see that it works. So we have, think of it like this. This course name is something that we have received. This TS is something, the string is something that we have received in our library. However, we want to have some sort of a price, a number. In this, using this implementation, we cannot actually come up with a way of understanding and knowing what that and preventing a string being stored in a variable of type number. And we have successfully done that. We have successfully done something that is essentially a bug. Now, how are we going to fix this? That is going to be our next example. Let's come down here. I'm going to copy it down here. Now, if we receive something in our library, we type annotate it to any, and then we put it in an unknown variable. That is going to give us some sort of a type safety. And in this case, we are going to see that type unknown is not assignable to type number. Now, in this case, what we can do is we can come up with a type narrowing whether conditional or logical, and then we would really know what the type of that is. So if I'm expecting a number, I can do the same kind of type narrowing that I've done right here. If I'm expecting a string, I could do that using a type narrowing, or any other type that we want, any other kind of narrowing that we want. We have already talked about type narrowing, type guards. So we can employ those kind of techniques to really understand what the type of this variable is. So this way is more recommended than this way. In the first method, which I'm just going to pass in not recommended, dead, and then I'm going to copy that. You know what? Copy both lines. Whoops. Let's put them there, and I'm going to pass it right here. Save that. Now this is recommended because instead of having a runtime error, we do want to end up with a compilation error. So this compilation error we fix before actually publishing our library. Now these are the kind of edge cases that you need to be familiar with and you need to keep in mind. Now that we have an error, we can come up with a way to actually narrow the type and then really understand what the issue is. So what the type of the input is. So I'm going to comment that one out. I'm going to paste it down below. I could say type of, if type of course price is equal to number, then I just want to have that number. Otherwise, I'm going to have 9.99. I'm going to save that. Now, in this case, we know that the type is a string. And therefore, we fall back to our default value, which is 9.99. Now, this is a very, very good use case of the unknown type. And you saw if we do the reverse of it, we assign it to unknown, and then we pass it into any, then we effectively take out the type safety. But in this case, we still have our type safety. That is why this way is recommended. The final couple of examples. I know this lecture is getting a little bit lengthy because I just wanted to cover everything you needed to know about the unknown type in just one lecture, everything in one place. So you can have it as a reference. Now, there are two more things that I would like to talk about: the unknown type with a union type and the unknown type with an intersection type. You need to keep in mind that the unknown type, in the case of union, unknown absorbs the union type. But in the case of intersection type, the intersection absorbs the unknown type. And these are basically the why is within the nature of the union type. So if you don't know the type of something, adding another type to it, you might still end up with not knowing the type. But in the case of the intersection, if you know the type, for example, if it is a string or a number, and you add unknown to it, what you have effectively done is you still know that the type is going to be string. Therefore, an intersection absorbs the unknown, but a union is absorbed by the unknown. And you need to keep this in mind. Let's say we have a course name variable, and I'm going to assign it unknown or string, since this is the union type, and I'm going to pass in TS. Let's say we have another variable like product, and I'm going to type annotate it to string. Now, as soon as I pass in course name, there is going to be an error. Why? Because it says type unknown is not assignable to type string. But what happened to this string? Because of the nature of the unknown, it was absorbed by the unknown. So if we don't know the type and then we pass in another type, chances are we still don't know the type. All right? And the actual case is going to be reversed when we are talking about the intersection types. And I could give you like another example here as well. Now, I have passed in something that looks like a string. Let's comment it out. And let's pass in something that looks like a number. And this is what I meant by if we don't know the type, and if we pass in another type, chances are we still don't know the type. And this is exactly it. Now, if before jumping into onto line 45, on line 44, we can see this is perfectly valid. Even though this is a number, And we have said, okay, a union of unknown and string. And again, the same thing. We don't know the type. And if we pass in another type, chances are that we still don't know the type. And this is the same thing. Even though we have changed the type, it is not telling me that this is a number and you have type annotated a string to it. Now that you know how unknown type works with the union type, let's take a look at the unknown type and the intersection type. In the case of the intersection, unknown will be absorbed by the intersection type. And the reason for that is because if you know the type of a variable, which is, for example, a string or it is a number, then if you add unknown to it, chances are you still know the type. And that is how it actually works. I'm going to take a look at the same example for that one as well. Let's take a look at this. Let us change this to an intersection. And now as soon as I comment this one in, it's gonna work. Because even though on this side we don't know the type, but on this side we know the type. And this is an intersection. So these two types have to intersect together, like intersect one another. And then when they intersect, we know on one side we know the string, the type, on the other side we don't know. So what we are ending up with is that we know what the type is going to be. I'm going to comment that one out and I'm going to take a look at this one. And if I take a look at that one, now we can see that, okay, let's convert it to an intersection first. And now we don't jump into the product. We have the same error. We have the error right in the variable declaration. It says type number is not assignable to type string. So this 25 is not assignable to the variable string. So out of these two types, the type that triumphs or that survives is going to be the string because of this intersection. But because of the union, out of these two types, the types that comes on top is going to be unknown. So when it is unknown, you can assign a string to it. When it is unknown, you can assign 25 to it. But when out of these two types, a string comes out victorious, we can't assign a number to it because the type is string. We get our normal type checking in TypeScript. And then in this case, we don't really need this unknown here anyway, right? And you might be thinking, okay, what if we assign to this variable course name the value unknown? Well, you can't do that really because unknown is a type. You cannot use it as a value. So if I were just to do this, if we take a look at here, it says unknown only refers to a type, but it is being used as a value here. So you need to keep that in mind. So I think with this, our lecture has come to an end, and we did cover a lot of things. And if there is anything that you're not feeling comfortable with, you can always go ahead and rewatch the video. That is it for this lecture. See you in the next one. Hi everyone, in this lesson we are going to talk about index signatures. Index signatures define the entire signature of an object using indices or the keys of an object. The keys of an object is an integral part of index signatures. Defining the signature of an object is completely different than defining the shape of an object. When we define the shape of an object, the object cannot have any other shape. And it has to comply with the pre-created shape and must include all the members defined clearly. But an object signature is different. How is the aim of this lecture? First off, let's take a look at a very, very simple type alias that we know, and we know how we can work with that. Let's say this type alias is going to have one property, and that is going to be of name type string. I'm going to create a variable course, type annotated to this product. And now the only thing that I have to do is I have to follow that specific criteria, one property with the type of string. And I'm going to pass in bootcamp. Now this is good. This is really, really good because we can't do any kind of typos. We cannot add anything else. So the shape is extremely rigid. So it is type safe. But what if we want to add more courses to it? Let's say we want to add a TypeScript course, a JavaScript course, a Python course, whatever. Now in that case, we are not going to be able to do that because there is going to be an error, right? Because that is not going to follow the shape that we have created for it. But, and I could show you using another property like price. If I set it to 10.99, and as soon as I take a look at that, it says price does not exist in type product. So it doesn't exist, so it doesn't work. But this inflexibility or this rigidness is something that index signatures solve for us. Of course, with every new tool that you learn, there are some advantages and then there are some disadvantages that you should really know and really understand before adopting that tool and basically like abandoning the previous tool completely. Every tool, every technique has its own place, its own application. Let's take a look at an index signature, and then I'm going to break it up piece by piece what that is. An index signature is something that provides the signature for the keys of an object. What the flexibility that index signature provides is that you can have as many keys as you want. And their names, the literal key names, could be whatever you want. But the key type and the value type is something that you need to define beforehand. So in this case, the key name could be anything, and I'm just going to pass in K. I'm just going to pass in K, nothing else. But what is going to be the type of the key? In this scenario, when I say name that has a type of string, I am not literally and directly specifying the type of the name key itself. This string refers to the value type, the value that the key holds. But what is the key itself? The key itself is consisting of 4 letters, NAME, which constitute a string. So it is a string, the key is string that holds a string value. Now index signatures do the same thing. Now the key could be of any type, number or string. I'm going to say that the key is of type string, but what is the value that the key holds? What is going to be its type? Let's say its type is going to be string as well. And congratulations, you just created your very first index signature. Index signatures are extremely important when it comes to understanding advanced types, understanding the source code of TypeScript. So you really need to pay attention what this index signature is. It's going to play a major role in our upcoming advanced types sections, and you really have to master this syntax for an index signature before even moving on to those sections. So I'm going to go over this once more. We have a key that could be anything. It could be TypeScript, it could be JavaScript, it could be anything. As long as it is a string, as long as its type is a string. So it's like a string of anything. And the value that key is going to hold is going to be a string as well. And I think that is the simplest explanation. Let's create a course product and let's take a look at an example. We have this product. Now in here, you can see there is no kind of error. So I don't have like limitations as how many members I can add. I could have a course TS with the name TS Bootcamp. And you can see that I have specified here a K, like a placeholder for the key, because it doesn't matter. You can write here K, you can say name, you can say names, you can say course names. Just make sure you provide the kind of placeholder that delivers your intent. What do you want to do with this index signature? So providing something vague as K is not really a good thing, because it doesn't really convey what it is that I'm trying to do here. But the reason that I've done that is just to show you can pass in as anything you want. So it could be of type, but now you can see TS is of type string itself, TS letters, string, and then the value that it holds is going to be string as well. If I remove the value and if I pass in a number, then there is going to be an error. Why? Because the expected type comes from this index signature. Type number is not assignable type string. This has a type of number, but the index signature's type is a string. Keep in mind, the index signature's type in this case is a string, whatever comes after the last colon. All right, let us do that. Let's say we want to add another course, JS Bootcamp. You can do that, but you can't do this with a type alias, with defining the shape of an object. We could add in Python, and then I could say Python Bootcamp. As long as the types match, everything is going to be okay. So this is a string, this is string literal, and then this is string literal. As long as the types match, it's going to be okay. So now that you really understand this, I'm going to comment this one out, put it down below. I'm going to specify a key that delivers my intent. And what do I want to create? Do I want to create a list of names, a list of product prices, whatever? I want to have a list of course names. So I'm going to say that course name. You can see this course name is not used here. It's not necessary to use it. Just follow the type of it, and you're going to be okay. Now, this flexibility comes with some downsides as well, and we're going to talk about that in just like in another example after the upcoming one. I'm going to comment this one out. You might be thinking, now that we have that index signature, can we actually use other normal properties in here as well? And yes, you can do that. Let's say I want to create an index signature that specifies price, whether something is priced. Now, the type of this is priced key. The actual literal key is going to have a type of string, but the value that the key holds is going to be of type number. Now, when you have this and you want to add another regular property, your object has to comply with that shape. When you add in a regular property, you're defining a shape for your object. So your object has to comply with it. And I'm going to say released. And I'm going to assign to it a value of, now this is price, sorry, this is Boolean. This is priced, it's like a question, is priced, yes or no, true or false. And released, I'm going to assign it a value, a type of Boolean as well. Now, where is the issue? The issue, we're going to talk about that in our next example. So in this case, we can see that we have a key, and the key literal itself has a type of string, and the value that it holds is going to be Boolean. And then we have a regular property for which the name is released, and the type of it is going to be Boolean. Let course product. Now, I could create as many courses as I want, so I can say TS. Yes, TS is priced. JS, yes, JS is priced. But then there is going to be an error because we are leaving this released behind. In the previous example, there wasn't any kind of error because we didn't have a shape for an object. Now we have specified a shape. This property is part of the shape of the object. And I need to reference it here as well. Released. Released. I need to add in a comma there, and I'm going to say true. And now everything is okay. So as far as this index signature is concerned, I can add as many things as I want, but as far as the released is concerned, it's like a normal shape of an object. I can just have one released property. Let's say I'm going to have another one, and I'm going to say false. For TS, I'm going to say release true. For example, for JS, I'm going to say false. And then there is going to be an error. An object literal cannot have multiple properties with the same name. So you can't have that. All right? Let's take a look at an issue that could be created when we are using index signatures. And I'm going to take a look at the same example. Let's put that here. Let's comment this one in. Now, even though it provides us with some flexibility, the issue that arises with index signature is that whatever property that follows the index signature has to have the same type as the index signature. What is the type of the index signature in this case? It is Boolean. The type of an index signature is the type of the value that the index signature holds. What is the type of released in this scenario? It is Boolean, so both of them match. But what if I say priced? Instead of is priced, I'm going to say price. What is going to be the price? and I'm going to change the Boolean to a number. Now there is going to be an error. Why? Because released of type Boolean is not assignable to string index type number. String index type. String, the type of the index or the key is string, but the index signature has a type of number. Now you can see this is number, this is Boolean, they don't match, there is an error. So this is something that you need to keep in mind. And finally, let's take a look at how index signatures allow us to create something called a dictionary. So if you come from Python, you already know what dictionary is, but you can create a dictionary with an index signature as well. Let's say we have a type product, and I have a key, an arbitrary key of any name, but the type of that key has to be string, and then the value of the key is going to be another object, and therefore this is a dictionary. The dictionary is something in JavaScript and TypeScript for which the value is another object, right? And then I'm going to pass in here a name with the type of string, and a number with a price with the type of number. And I'm going to save that. Now, how are we going to create a variable from this or an object from this? Let's do that. In this case, the keys could be whatever we want, but the value that the key holds, they have to be an object. So they should have a name, which I'm going to pass in TS Bootcamp, and then they should have the price property as well. Price 10.99. Everything is cool. Let's copy it 2 more times. For the second iteration, 9. For the third one, 11. This is going to be JS, and this is going to be Python. This will be JS and Python. So the keys could be anything that we want, but their values, again, they have to specify, they have to follow this exact shape. And this is a dictionary. That is it for this lecture. See you in the next one. Hi everyone. In this lesson, we are going to talk about indexed access types. With an indexed access type, we can access some part of a type with another type, much like when we access the keys of an object. Let's first take a look at how we can access the keys of an object, just as a refresher. Let's say we have this object called product. It has a name TS, and then it has a price property of 10.99. Now, how are we going to go ahead and access that? Let's say we want to get the course name, and we want to access the name from this object. Then I have to provide a reference to the object using the bracket notation or the dot notation. I can access the properties or the members. I'm going to do it using the dot notation, and then we can do the same thing using the bracket notation as well, where we pass in the actual name. In both cases, we can access that and we can log it to the console. Now, an indexed access type is the same thing, but for types, like interfaces and type aliases. It does the same thing. It accesses some part of that type using another type. So how are we going to do that? We're going to take a look at that in this lecture. So we have a type product, type alias. There is a name with the type of string. The value that it holds is string. And then there is a price with the type of number. Everything is cool so far. Now, let's say I want to create a type for which the name is course name. And since I'm talking about course name, I'm interested in getting this property that has a type of string out of this type alias. So how am I going to do that? I'm going to I was about to say something in Persian. I'm going to employ the same technique. I'm going to reference the type first, but there is a limitation. I can't do the dot notation. Dot notation does not work on types. I can only access the properties of a type or index into that type using the bracket notation. And as soon as I do that, now if I hover on the course name, we can see, come on buddy, we can see that it has a type of string. Now I can use it wherever I want. Const course name, type annotated to the course name type. and let's pass in TS, and everything is going to work fine. Course name. Let's save that, and we do see TS in the console. So we are indexing into this product type using another type, which is this course name. And that is indexed access types in its simplest forms. But this example is not that interesting. Let's make it interesting. Let's see how we can build on top of this. I'm gonna copy this part, and then I'm gonna comment this entire thing out, and we are gonna move away from it. Let's put that down below. Let me just scroll. So what I'm gonna do here is I'm gonna add a more info key here, more info key, and this is gonna be an object. This is gonna have a released property, which is gonna be of type Boolean, a beginner friendly DLY, which is going to be of type Boolean as well, and then a level, which will be of type yes string. Let's pass in the G there as well. So we have this type product, and I'm going to create a function. The aim of this function is to promote this product. Promote product. And I'm going to pass in the name of the product, which is going to be of type string. I'm going to pass in the price of the product, which is going to be of type number. But there is something else that I want to do here as well, and that is, how can I get this more info, this released, beginner friendly, level? How can I put that into the function definition? Well, that is where that is where we can use an indexed access type. This is an application of an indexed access type. And how are we going to do that is going to be in the same way. First, we actually need to provide the parameter, what the parameter is going to be. Let's say the parameter is going to be more info. Now, the type annotation, first reference that type product, and then using the bracket notation, we get the more info. And you can see there is that pop-up, more info. So everything is working perfectly fine. We need to create a function body. Now, what is this function is going to return? What the return type is going to be? It's going to be that product. So return an object. Now, we have already talked about when a key and a value have the same name, we can just write one of them. So instead of saying name, for which the value is name, I can just say name, comma, price, comma. You can see more info, and this more info, both of them look the same. So I can just repeat it once, and now the error is gone. Since we have created our function, let's pass in something to it. Let course info promote product. And what do I need to pass in? I need to pass in the name, I need to pass in the price, and then I need to pass in the object, for which there is going to be a released. I'm going to say true. Beginner friendly, I'm going to say true. And then level, I'm going to say beginner to advanced. Cool. And everything is looking awesome. Let's log it for completion's sake. Course info, and there we go. Here is our object, and here is the object within there. Now you need to keep in mind that everything that we have done with a type alias, we can do that with an interface as well. So we can index into an interface too. And how are we going to do that? I'm going to talk about that very briefly because they're extremely similar, and I don't need to waste too much time. Let's say we have this. Where is our type? I'm going to get this. I'm going to put it down here. I'm going to convert this into an interface. The first thing is the interface keyword, and then get rid of the equality sign. That's it. This is an interface. And how are we going to index into this interface? It's extremely simple. I'm going to say I want to have a course name variable. I'm going to type annotate it to the product. Now in this case, this product is the interface that we're working with, interface product. And I want to get the course name, so the name property. Let's assign it TS. We could extract the price as well in the same manner, 10.99. This is going to be price, and this will be price as well. It is going to work. But what if I want to take a look at the beginner friendly part, or the level of this product, the level of this course? How can I, because that is nested. Well, we are going to do the same thing as we would do with objects. We are going to do 2 brackets just for one level deeper. So I'm going to say course level, type annotated to product. So first I'm going to get the outer one, which is going to be more info. And as soon as I do the second bracket and I open that, we can see we have access to all of the properties within the more info key. And I want to take a look at the level. And I want to basically type annotated to beginner to advanced. Where is that string? It's right here. Put it right here. And that's it. And actually, there is one more thing that I would like to talk about, and that is indexed access types with unions. You can also do that as well. For example, we can say course info. I'm going to type annotated to product, and in here you can use a union type as well. So let's say you want to grab the name, or you want to grab the price. In this case, what you can do is you can say 10, which is going to satisfy that because that is of type. That is going to be in line with the price property, and you can do TS, which is in line with the name property. So you can go both ways. I'm going to comment this one out. This could be a price as well. There we go. So you can do that as well, like using a union type in your indexed access types. That is it for this lecture. See you in the next one. Hi everyone, in this lesson we are going to talk about partial types. A partial type is a flexible way to create an object that could contain some or all of the properties, but none of the properties are required to be existent within the object. Let's say we have a type alias called product, we have a name type string, and we have a price type number. Now if I create an object from this, I know that everything is required. I need to pass in both name and price. But what if they're not required? How am I going to do that? Well, one way to do that would be to provide in question marks there. So if I add in a question mark here, and then if I add in a question mark here, let's say course type product, and I could pass in 1 or nothing. I could just pass in nothing, and it would still work and there is no error. And you can see that it's an empty object. I could pass in TS, or I could pass in the price as well. Now this is an optional. The properties of this are optional. Now it is cool to handle it like this, but TypeScript in fact has syntax. Let's take a look at that syntax. Before actually jumping into the syntax, I need to give you a heads up that this is going to be your very first interaction with something called mapped types. Map types are an extremely important concept in TypeScript, and they leverage the concept of index signatures. That's why I really emphasized on index signatures, because they're really important, and you're going to see that in almost all major source codes that rely on TypeScript. So this is going to be your very first interaction with a map type, but there is going to be the abstraction is going to be like removed. We are going to abstract away the complexity of map type, because we are going to use a specific keyword for a partial object, and that is like a partial keyword. And then I'm going to show you what that map type for that partial would look like, what you are going to see in the source code. So what I'm going to do is I'm going to create our type. I'm going to get it from here, put it down here. Let's get rid of these 2 question marks. Let's comment this one in. All right. I'm going to create a course variable from this. Now the syntax for a partial type is you just write partial, and then angle brackets, you pass in the type that you want to make partial. And now you could pass in everything, you could pass in nothing. So it serves the same purpose as having 2 question marks for these 2 properties. Now, why am I saying this is a partial type? This is a mapped type. If I hover on the course name, we can see that it says partial. If I hover on the partial, and just don't be scared by taking a look at this, and this map type says make all properties in T optional. We already know what T is. We have not talked about the key of. We are going to talk about that as well. But what you need to keep in mind is this question mark. This question mark and this syntax, it looks like an index signature because it is an index signature. And this is the syntax for making every property of a type, be that an interface or a type alias, making every property optional. So if you have 100 properties with just this partial keyword, you can make all of them optional without having the need to provide 1000 question marks or 100 question marks. With just this, you can make everything partial. Another way of taking a look at that is going to be you hold Control and then you click on this, and then you're going to get to this file d.tsd, stands for declaration. So this is the source code of TypeScript. This is how TypeScript works under the hood. And we are going to come back to this partial. This is partial. I'm going to explain all of that. This is required. We are going to talk about that. This is read only. This is pick. This is record. This is exclude, extract. We're going to talk about all of these in their specific sections, in their specific chapters. Don't worry about this. This is just, you need to really understand what these are. If you don't, you won't be able to understand how TypeScript works. So TypeScript is not just types. It's so much more than that. It's like an extremely powerful programming language. So it has to come up with ways to handle or to tame all the wild JavaScript code out there. So TypeScript had to evolve to a point where we end up with these complex types, just to make sure that our TypeScript applications, they work with every major and every existing funky and quirky JavaScript code. All right. So how are we going to work with this? We could provide a name that could be of type TS. We could provide, if we wanted to, I guess, that. But we could provide nothing. And everything is optional anyway. If you hover on it, it says the same thing here. Make all properties in T, which is our type, this type optional. So this is a partial type. Now, I think... yeah, there is one more thing that I would like to talk about, that if I hover on the name TS, we're going to get undefined. Why? Because this is optional. Take a look at this question mark. When a property is optional, there is a good chance that that property may not be known. So it is undefined. Therefore, if I just take a look at it like this, if I say course dot name, if I get the name and if I set it to JS, I could do that. But you need to keep in mind that this name, it could be unknown. We may not know what the name is. So what we end up with is a very flexible object that we are not going to be, unfortunately, able to type check. We are not going to be able to see which properties we have, which properties we don't, but it is going to be a flexible object. So we could create the object and we could later on populate that object with some properties. All right. So I think there is one more thing that I would like to show it to you. Let's say this JS, I'm going to comment this one out. I'm going to pass in a name property of TS. Let's say I want to get the value of this TS and store it in another variable. What are going to be the repercussions in that scenario? What I'm going to do is I'm going to say, okay, I have a course name and the type of that. Since this name has a type of string, it's safe to say that the course name has a type of string, and it should work. Let's get the product. Whoops. Let's get the course, and as soon as I do the name, there is going to be an error. Why? Now this is what is the issue with this undefined. Now what we are trying to do is we are trying to store something that has a broader scope when it comes to type. It is a type of string and undefined into something that is smaller in scope. just string, and therefore there is an error. Type undefined is not assignable to type string. So you need to keep this in mind, that these things you can't do really directly with when using a partial object. And with this, our lecture comes to an end. See you in the next one. Hi everyone, in this lesson we are going to talk about read-only types. Read-only types are the kind of types that all of their properties are read-only. You cannot change them. We already know how we can make any one property read-only. Let's say we have these two properties, name string and price of number. We know how we can make any one property read-only, and that is using the read-only type modifier, read-only. But what if you want to make everything read-only? What if you want to make all the properties read-only? How are you going to do that? Well, there is a map type for that as well. We kind of saw that like very, very briefly, just a glance at it in our previous lecture. And this one we are going to take a look at in basically an abstracted away version of that, a very simplified version of it. And that is going to be implemented in the same way as our, come on buddy, previous lecture's partial type. We're going to create a product called course, type annotated to our product type, and then we need to specify that this type is actually read-only. And for that, we just have to write read-only. And as soon as I do that, I can pass in TS, and I can pass in price 10.99. Let me just provide the comma there, and let's save that. If I hover on the read-only itself, it says make all properties in T read-only. Previously it was optional, now it is read-only. And you can see that read-only type modifier in front of our index signature. So it's like a very good exercise for you, that your eyes are getting used to this syntax. We're going to talk about all of this in our upcoming sections, but it's good that you're getting familiarized with that. And if you do Control or Command, I believe in Mac, click, you're going to come to actual declaration of it in TypeScript source code, where it says read-only, and we pass in a generic type. This type could be anything. And then we say that we want to get the keys of all that type, and we assign it that generic type. So we are going to get to this because this key of is an important part of all these mapped types. Read-only is another mapped type, much like partial in our previous lecture. And let's log this so we can really see that it works. Course, and we can see that in the console. But what if I want to change some property, for example, .name, and I'm going to set it to JS. As soon as I do that, it says cannot assign name because it is a read-only property, even though we have not used any kind of read-only there. There is another implementation for this read-only as well. I'm going to comment this one out, put it down below. And it is going to work for our partial as well. For example, you're not feeling like writing that here. It may like confuse you, like it may be hard to read. And you want to apply it on the actual object type or type alias itself. Then this is how you're going to do that. Before defining the object type, you're going to write read-only, spell it correctly, and then provide this object type within the generic, within where we provide the T for this read-only. And this resembles more like this that we have here. So T is going to be this type that we have here. Let me write that on one line so you can really see what T is going to be in this case. Okay, there we go. If I save that, all right. Now, if I take a look at that, in this case, you can see it says T, and in this case, T is name string price number. So T is whatever the shape of the object that we want to be. All right. So you can do it like this as well. You can do the same thing for that partial type in our previous lecture. Partial. You can do that. I'm going to say read only product, and I'm going to say partial In both cases, you're going to get whatever you want. Make all properties in T optional. What is T? What is T? T is this object that you pass in, the object shape. So all properties in the object shape, in this case, they're optional. And in this case, in the case of read-only, all the properties in the object shape, they are read-only. So it is very self-explanatory, even though it's like a very, very cool concept, very difficult one at that, but it is very easy to understand. All properties in T optional. What is T? T is this object, because objects have properties. And then here it says make all properties in T read-only, and read-only, which properties? The properties that are in this object. And now there is an error here because we have changed the type, the name of that type. It is read-only product. And keep in mind, I have capitalized the O, so it is different than the one that we have for TypeScript source code. The actual keyword is read-only, except for the R, everything's lowercase. But what I've written here is intentionally the O is capital. So there is a difference between these two. All right, and that is it for this lecture. See you in the next one. Hi everyone. In this lesson, we are going to talk about read-only arrays. A read-only array is an array that does not support methods that change or mutate the array in any way. If we have a normal array, like array of numbers, and we type annotate it to an array of numbers, if I have 1, 2, 3, 4, and 5, we can change this array. For example, I'm gonna log this down below, and we are gonna keep the log below. And I'm gonna work above this, so we can see how the array is actually changed. I can get the numbers, and I can push another number there, for example, number 6, and we can see the original array is changed. We have 6 there. We can sort these, for example, numbers.sort, and as soon as I do that, it says 1, 2, 3, 4, 5. Let us change the arrangement for, this is going to be 5, this is going to be 3, this is 2, you know what, 3 and then 2. And if I save that, we can see the array is sorted. I'm going to comment that one out. It is not sorted, now it is sorted. And in both cases, we are actually changing the array itself. But what if I store this array inside another variable and then I change that variable? Well, let's take a look at that. Const nums instead of numbers. I'm not gonna type annotate it. I'm gonna say this is assigned to numbers. If I take a look at the type, we know this is an array of numbers. And I'm gonna take a look at the nums as well. But first, let's pass in here a string. So original array. And this is going to be copy array. Copy array is nums. As soon as I save that, we can see copy array and original array, both of them are the same. Now, if I take that copy array, and if I try to add another value there, like 7, and if I save that, something that might be weird to you, it happens. We see that we have 7 in our copy array, but we end up reflecting that in our original array as well. Now, the idea behind this is, the reason that this happens is because of the idea of storing. This comes actually from JavaScript. Storing by value, and then storing, come on buddy, storing by reference. Now, primitive data types like numbers, strings, and booleans, they are stored by value. What do I mean by that? By that, what I mean is, for example, let's say I have my name. I'm not going to type annotate it. I'm going to say Muslim. And later on, I change my name. Let's store it in another variable. How can I show this to you? Stored by values, stored by reference. I'm going to store it in this variable, new name, and I'm going to store here my name. We're going to take a look at both of them. My name, currently we know that it is going to show Muslim, and new name is going to show that as well. So new name is going to be Muslim as well. In both cases we have that. But if I change new name to something else, for example John, and if I save that, we can see that the original one is still Muslim, but this new name is John. Or perhaps a better example would have been if I change this my name to John, and now this basically reflects that change better. My name, I'm gonna provide it a comment there, original name, and let's say new name. So original name, it was John, it was Muslim, but then I changed it to John. But you can see new name is still Muslim. It is not something else. So I need to provide a colon there so it is understandable. Now new name is Muslim. Now why didn't this value of new name change? Even though we changed my name here to John, this new name should have been changed to John as well. But new name is still holding that value that we changed. The reason for that is that these are primitive types. They are stored by value. So my name is an identifier that points to something called Muslim, which is a string in memory. And then new name points to a value. It doesn't point to this identifier. It points to that value of Muslim. So assigning my name to new name is effectively saying Muslim. So these two, and you can see these two are independent. They have the same value, but they are two different variables. And primitive types work in that way. There are two different basically identifiers pointing to two different things. This Muslim is one thing located in memory, and the Muslim that is in this new name, that is a completely different thing stored in memory. They happen to have the same characteristics, but they are completely different. And this is why it's called stored by value. We store the value. But for more complex data types, like arrays and objects, we don't have that store by value. We store by reference. So when I assign numbers to nums, I'm not storing 1, 2, 1, 4, 5, 3, 2 in numbers. I am assigning, or I'm storing a reference to this array. Now in both cases, numbers and nums, they are two identifiers that point to the same array. But in this case, we had two identifiers that pointed to different values. So in this case, the value is the same. We just have two things that point to it, like two vectors that point to it. But in this case, we have two vectors, and then we have two different things that they point to it. This is the nature, that this comes from JavaScript, and it is implemented in TypeScript as well. This is called stored by reference and stored by value. This is like an extremely important concept that you really have to master. And this is why you can't, like, if you do this, you're thinking like I'm storing this array, a copy of it, and then when I change, you can see the original array is changed as well. Because you're not storing the array, you're storing the reference for that array. So when you change, when you have one object in memory, one thing in memory, there could be 10 things pointing at it. If you change any of those 10 things, that thing is going to change, because that thing located in memory, in this case this array, is dependent on all those 10 pointers. There is no one pointer more important than the other. So as soon as I assign numbers to nums, nums plays as important of a role in creating this array and modifying this array as the numbers variable does. They have the same role. I can't say that nums is a copy array. No, it is not correct. It is not a copy array. Nums is still referring to the original array. Even though it might seem like this is a copy array, I'm going to pass in copy here just to identify between those two. But at the end of the day, both of them are original arrays because they point to one thing. But in the case of storing by value, they don't do that. Now, why did I just digress too much and just went off track? Because what read-only arrays do for us is they restrict this behavior. How, you might think? how you might say. Let's go ahead and let's take a look at that. Now, what I'm going to do is I'm going to create an array here. And by the way, objects are stored by reference as well. So if you create an object, I could just show like a very small example of that. I'm gonna try. I do have the example right here, so I could just copy paste that very well. Just go over the example since that is extremely simple. Let me put that there as well. Comment these ones in. So I have an original object named TS, and then I log it. Very cool. Then I put that object inside another variable, copy object, and then I change the name from TS to JS, and then both of the instances, they're going to change. And if I save that, you're going to see that here. So I have a TS. So originally on line 13, I have not changed anything. So that's why it prints TS. I'm going to get rid of it just to remove any kind of confusion. I store this object in this copy object, and then from the copy object, I change the name properties value to JS. And then if I take a look at the copy object and original object, both of them have the same value for the property name, because objects are like arrays. They're stored by reference. Even though this might seem like it has been stored in two places, but there is actually, we're storing the reference of the original object into the copy object. We are not storing the object directly itself. We are storing the reference of it. So when we change, like if an object has 10 references, if I change any of the references, the object is going to change. Cool. Let's take a look at an array, a read-only array. We have, let's say we have a const numbers. Now a read-only array syntax is like this. We have read-only, and then I'm going to pass an array. And you can see that, I'm going to just show it to you again. We have a read-only map and read-only set as well. Read-only array. And this is going to be what type of the array you want. I want to have an array of numbers. So I'm going to say 5, 2, 3, 1. Now, since this is a read-only array, the push method is not going to be available. Dot push, and as soon as I do that, if I take a look at that, property push does not exist on type read-only array of numbers. Let's take a look at the sort one. Dot sort, and if I do that, it doesn't exist. Why? Because even though sort is the array, but it changes the array. How? Because now what is the index of the number 5? It is 0. But if it sorts it, the index of number 5 is going to be 3. So it fundamentally changes the array in some way. But don't worry, the methods that do not change the array, they're still going to work. For example, I'm going to log that for you. Let's say we have numbers dot index of 1. If I store that, what is it going to give us? 0, 1, 2, and 3. This is going to give us 3. This method is available. And I'm going to give you another property that is available as well. Just static methods and properties that do not change the array. And we can see the length is 4. They are available. Only the properties that change the array in some way, they're not available. And this is a read-only array of numbers. You can create a read-only array of strings as well. I could say strings, extremely generic, read-only array, and then you need to pass in the data type, which is going to be string. Hi and hey. Save that, and that is it. That is it for this lecture. See you in the next one. Hi everyone. In this lesson, we're going to talk about shared fields. Consider the two type aliases in front of you. We have a type alias called product, 5 properties. One, we have course, 5 properties. However, there are these 3 properties that are repeated twice. We have name, string, price number, sales number, and then we have the same thing right here. Now this makes our code really bloated, and we have to come up with like 2 different, what if there were more properties that were like similar? Then we would have We would want to repeat that here, and we would want to repeat that here. But before fixing this issue, I'm going to create an object that uses these types as its own type annotation. I'm going to create a type, like a general type, that is going to leverage both of these types. I'm going to say online course is going to be equal to product, and then union course. So there are some properties available in here, like availability and category, that I require. And then there are these two unique properties here, released and rating, that are required to be able to create my object. Const course, I'm going to type annotate it as the online course. And let's create these properties. So what I'm going to do is, instead of writing all of them, I am just going to copy that, just not to waste your time too much. Let's say we have all of these. Now we have name, price, sales, released, and rating. What about this availability and category? You could provide them. You could not provide them, because this is a union type. All right? But if you wanted to provide them, this is how they would look like. We would have availability, available, and category is going to be web dev. And you can see this approach is extremely bloated. What is one way that we could get rid of this, or make it shorter? That is where shared fields come into the picture. This is like a very cool concept in TypeScript that we can leverage. And I'm going to comment both of these in, and we're going to take a look at how we can come up with a shared field. Now, a shared field is exactly as the name suggests. It is a shared field. I'm going to log this so we have something on the log. There we go. We have object right here. Come on, buddy. There we go. So what I'm going to do is I'm going to get rid of these repetitive properties. And what I end up with is like these unique properties. And then I create another type alias. And I'm going to call that digital, whatever you want to name that, that is okay. Digital product. So I have these name, price, and sales. How am I going to use them in this type and in this type? Well, that is where, again, shared field comes into the picture. So you're going to grab the shared type's name, and then after the equality sign, you're going to put that there, and then you're going to use the intersection operator. Put it right here, and then intersection operator. So what this essentially says, that the type alias product has these three properties, and then it has availability and category. The course type has these three properties, and then released and rating, but without actually having to write them 2 times. And then you can see it works. This is one syntax for a shared field. There is actually another syntax for it as well. Let's save that, and we're going to take a look at that next. And that syntax might be like more readable for you. So the way that I'm going to create that syntax is just going to be a series of copy pastes. So first, let's take a look at this one. Where is this product located? We locate that after the equality sign, right? So this type product, where it inherits these properties from the digital product, we pass in digital product after the equality sign. Okay, so that is point number 1. Point number 2 is we use this intersection type. So we need to keep in mind these 2 points. So after the equality sign, I say that I want these 3 properties to be bestowed upon as many other types that I want. So after this equality sign and after the object itself, why the object? We have the equality sign, and then we have the digital product. What is digital product? Digital product is this object that has 3 properties. And then what do we have after digital product? We have the intersection. So I'm going to pass an intersection, and then I'm going to open a parentheses, and I'm going to hit enter. So within the first pair of parentheses, within this pair of parentheses, I need to create an object because I am creating a type for an object. Let's get these 2. I'm going to cut them, put them right here. Very cool. And then I'm going to come down here, create another object, and you can see there is an error. We are going to fix that error. I'm going to get that. I'm going to put that here as well. Now, there is an error that says Boolean only refers to a type, but is being used as a value here. No, I'm not using it as a value here. So what is missing? The thing that is missing is this union type. So let's get rid of these two. Everything is making sense, right? If I were to put them side by side, what do you think would happen? So if I cut that, put it right here, and then let me just inline both of them. I want you to really see what is happening. So you can read that. Prettier is going to format that, so you don't need to worry about that. We have one object there. So what is going to be the relationship between these two objects? The relationship is going to be union. And now you can see the error is gone. And now I'm going to cut this, put it right here. Let's inline, and let's not inline, let's put the properties on one line. And come on, buddy. Let me just decrease this in size so we can really see what we're working with. And where is the parentheses? There we go. So this is what we actually end up with. We have that digital product, and then we have the intersection type. Then we pass in our as many type aliases or as many types or as many other unique properties that we want in this kind of set of objects. So if your product, you would want it to have two more properties like level and what could be like features. Then you're going to provide another union type, and then you're going to provide another object. And this is going to be a shared field. This is actually another syntax for a shared field. Now, we don't need this one either because we did that union. Now, as soon as I save that, you're going to see something like this, which is more readable. We have now the reason that there are two union types, even though we had one, is because of that prettier. As soon as it does that, it has to provide one before every object. But there is actually one. And if there is an error here because we don't have that type, let's type annotated to this. And now if I save that, everything is going to work perfectly fine. So I think in a way, this syntax is like how many lines? We have 62 to 69, almost 7-8 lines, as opposed to this one, this big one, or as opposed to this one, this gigantic one right here. So you can see this is shorter, more concise, more readable, and it is more understandable. We have these properties, and then we bestow these properties upon this object and upon this object using an intersection operator. Basically the same thing, rewritten in a different way. That is it for this lecture. See you in the next one. Hi everyone. In this lesson, we're going to talk about optional chaining operator. Let's say we have a type called product, and we have a name property of type string, and also we have an info property that has a type of product info. Now, product info is another type alias which we are going to create, and we haven't done like a type alias within another type alias. And there is another type for this one which is undefined. Now, this one it can't find because we have not created that. Let's copy that, put it down here, type alias, and what is going to be there? And there we're going to have a level of type string as well as a number of students, which is going to be, come on buddy, type number. Cool. Now, how can we create an object from this? Let's say we want to create an array of courses. So I'm going to say courses, plural, product, and I'm going to say an array of products. Let's pass in a D there as well. So we have an array of product objects. Keep that in mind. You can add this array syntax in front of a type alias as well. That would basically mean an array of objects if you want to create that. In this case, I do. Now, when I have an array of objects, the first thing that I have to do is create the syntax for an array, then hit enter for readability purposes, and then scroll down so we can see everything. And let's create, now within this array, every item is an object. So like that, and then hit enter for readability purposes. And what is this object going to have? The first thing it's going to have is going to be name. I'm going to say JS. And the second thing that is going to have is going to be info. Info. Cool. But info is another object. And within this info, we have a level that I'm going to provide beginner. And then there is going to be number of students that I'm going to provide as 2000. So everything is okay. Now, the issue is that, the thing is that, not issue, that I want to have an array of courses. This is just one course. Let me copy that, put it down below, and let's convert it to another course. So for the second course, I have TS. And I don't know the number of students. So I'm going to pass in undefined. I don't know that. So technically, I just pass in undefined. Now, there is an error because we have not actually handled undefined. I'm going to handle it here as well. I'm just going to say union undefined. And now the error is gone. Cool. Let's create another course. And that one, I'm gonna say Tailwind CSS. Tailwind CSS. For that one, I don't even have the info. So the info is undefined. Now, what do I want to do with this rather gigantic example? Let me put this on the side. We're going to come back to this JS since the operator that we talk about actually originates from JavaScript. Now, what I want to do is I want to map this array, map through this array, and get the number of students for every course. Now, if you know you can do that using a map method for an array, just go ahead, pause the video and do it. I'm just going to continue with the lecture. Now, if I go ahead and if I try to do that, I would say I'm going to do it within a log so we can see the result directly. I'm going to get my courses dot map. This is going to map every single array item. So whatever we get within the map is going to be individual array items. What are individual array items? They're objects. So that makes everything easy. So we have an individual course. And within this, I need to be within there. And for every individual course, I want to jump into the info and I want to get the number of students. Now, as soon as I do that, you can see the implementation of the optional chaining operator. This question mark dot, this is the optional chaining operator. It has been automatically added. If I save that, we can see we have 2000 undefined and undefined. 2000 comes from JavaScript, undefined comes from here, TypeScript, and the other undefined comes from the info for Tailwind. Now, it has been added automatically, but suppose it wasn't added. Then there is an issue that says course.info is possibly undefined. Now, how are we going to solve that without the knowledge of the optional chaining operator? How are we going to solve that? Perhaps you could say that we could come up with a conditional that would check for undefined values. Well, we could do that. Certainly, we could do that. Let's go ahead and do that. I'm going to say const course info, lowercase n, courses.map, and in here, I'm going to get every individual course and I'm going to check. What am I going to check for? I'm going to check if that course has an info. So I'm going to say if course.info exists. If course.info evaluates to true, it means that it is not undefined. Then what do I want to do? I want to return course.info dot number of students. Otherwise, I want to return undefined. Now, in this specific scenario, you do not need the else statement, believe me. Well, now that we have done that, let's log it as well so we can see it works, course info. And there we go, we get the same result. We get 2000, undefined and undefined. In the first scenario, in here, number of students exists. In the other two, it doesn't exist. And you might be thinking, all right, if I can use the if statement, I can use a ternary operator. Well, you're right. You can use a ternary operator for this as well, just to make everything shorter, right? And you're going to say, how am I going to convert it to a ternary operator? I'm going to keep this undefined. I'm going to convert this to this colon, get rid of this f, get rid of this, get rid of this one, basically convert it to a question mark, get rid of that, and let's put it on one line and save that. Well, in that case, you're going to get the same result. Not the same result. Why didn't we get the same result? So course.info.number of students. If this is true, I want to return let's save it again. It should work. Undefined, undefined, undefined. This comes from Ninja. Why is it undefined? And the first instance, number of students, number, then we have undefined, then it is undefined. It should show me that number there. It is showing me undefined. Course.info.number of students. If this is true, I want to return this. Otherwise, I want to return undefined. Well. Let me put this back here. Well, that is weird. It shows us, let me just copy that, comment these two out, and put that here. Well, it doesn't show us anything. It should show us something. And I think I know what the reason is. The reason is something very tricky with arrow functions, and that is an implicit return. Now, we are not returning anything from the function. When we have these curly braces, we need to return something from the function. And now it is going to give us 2000. There we go. But if I want to remove this return keyword, I need to get rid of this curly braces as well. Then it is going to be an implicit return. All right, and there we go. So I was doing an implicit return without getting rid of the braces for the function definition, function body. So you need to keep that in mind. Very cool. It's like these kind of little things that could throw you off. Now, this is an if statement. This is a ternary operator. In both cases, our result works. But there is actually a better way, and that is the optional chaining operator. Very simple. And the optional chaining operator basically says, and for that, I'm going to get that comment, put it down here. It basically checks against undefined and null. If something is null, or if something is undefined, it is going to return that. Otherwise, it's going to return the value. So if something is not undefined, it means that there is a value, and it is going to return that. And optional chaining operator was added to JavaScript in the version ES 2019. All right? So it is a really cool and modern feature. Now, since we are talking about the info, we know that the info, sometimes it is undefined, sometimes it is not. So I'm going to add a question mark. And as soon as I add that question mark dot is the optional chaining operator. The reason that we do have this dot here is for that dot notation that we access the values. And when I save that, we get the same result. So instead of like banging our heads on the computer and coming up with these conditionals, we could just add a question mark, and that is going to do the same thing as these ones. And this is called an optional chaining operator. That's it for this video. See you in the next one. Hi everyone. In this lesson, we're going to talk about knowledge coalescing operator. But before jumping into that, we need to review the logical AND operator and the logical OR operator. The logical AND operator's sign is double ampersands. For OR, we have two pipe characters, and I've provided you with some use cases and we're going to see that in the console as well. But first, we need to talk about them. Now, I'm sure you're already familiar with these AND and OR operators from your knowledge of JavaScript. These are like pretty basic stuff when you get started learning JavaScript. But what I want to do is I want to put these two in perspective so we know how knowledge coalescing is going to work. First off, the logical AND operator. The logical AND operator, it's going to look for the first falsy value that it finds. If both sides have a value of truthy, then it is going to return the second value. Now, everything in JavaScript is truthy, and the falsy values are 0, an empty string, false, null, undefined, and NaN. These are falsy values. So all these values that you can see right here, this empty string, 0, false, null, undefined, and NaN, these are falsy values. And all other values are truthy values. In case you're not familiar with falsy and truthy, if you evaluate a value in a Boolean context, when it evaluates to true, that value, we say that, is truthy. It means that it is not a Boolean true value per se, it acts like a Boolean true value. For example, if I take a look at the Boolean function right here, and if I pass in 1, 2, 3, now 1, 2, 3 is a number, it evaluates to true. So the number 123 is a truthy value. But if I take a look at an empty string evaluates to false. So an empty string is a falsy value. It is not a Boolean false, it behaves like a Boolean false. That is why it's called falsy. Truthy, like that. All right. The AND operator looks for the very first falsy value, and it is going to return that. If it can't find falsy values and both sides are truthy, then it returns the second value. So in this first scenario, it finds this falsy value, it returns it. So this first one is going to be an empty string. 0 is a falsy value, it's going to return that. False is going to be a falsy value, it's going to return that. Null, undefined, and NaN. So in these 6 scenarios, all the left sides will be returned. What about this one? So this is a string which is truthy. This is a string which is truthy as well. When both values are truthy, it returns the second value. So in this case, it's going to return hey. What about console log number, this one, line number 10? So it looks for the first falsy value and it returns that. So the first falsy value is going to be 0. This is truthy, 0 is going to be falsy, so it's going to return that 0 for us. And in these two, both of them are falsy. It returns the first falsy value that it finds. So for all of these, we are going to end up with the left side. For this one, hey, for this one, 0, and for this one, false. Let's save that and let's take a look at that. So 0, empty string right there, you can't see it. 0, false, null, undefined, NaN. And then we have hey, and then we have 0 and then false, exactly as I predicted that. Cool. Let's take a look at the OR operator. The OR operator is different. The OR operator returns the first truthy value it finds. If both values are falsy, then it returns the second value. So we have the first truthy value. 5 is truthy, returns 5. Truthy, 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 and truthy. So from all these 6 of these, it is going to return 5. And then what about this? These 3 right here. This is truthy, and this is truthy. Both of them are truthy. It returns the first truthy. So it returns high. In this case, it is still going to return high. And if both values are falsy, it returns the second value. So in this case, it's going to be 0. So we have, for all these, we have 5. Then we have high, high, and then 0. Let's save that. So 5, high, high, and then 0. So now that we know how these two work, let's jump into the nullish coalescing. But before jumping into nullish coalescing operator, keep in mind the logical AND operator and the logical OR operator, they evaluate 0 as a falsy value because that is what the Boolean function does. So if I pass in 0, it evaluates it as a false. So 0 is a falsy value. But what if you want to pass in the number 0? If you think about the number 0 itself, it shouldn't be false. It has to be true, much like any other number, like number 5. 0 has to be true. Now that is what the nullish coalescing operator fixes for us. The nullish coalescing operator always returns the left side of the operation, as long as the left side is not null and it is not undefined. If it is null or undefined, then it returns the right side. Otherwise, it's always going to return the left side. That is very simple. It is like the logical OR operator, but it does not treat the number 0 nor the empty string as falsy values. The empty string is also, we saw that, is a falsy value, but nullish coalescing operator does not treat it like that. And the symbol for it is double question mark. So from all of these, from this we are going to get an empty string, 0 and then false. And then since we have null and undefined, we get 5 and we get 5. And then we get NaN, we get high, high, and then false. Let's take a look at that. Let me comment this one and let's take a look at that. So we got empty string, 0, false. And then for null and undefined, we get the right side. And then we jump back into the left side. Even though NaN is falsy, we don't care because nullish coalescing operator just thinks about null and undefined. It doesn't care about anything else. And then we get the rest of them. Now the cool thing about the nullish coalescing operator is its name. It's not, you might think that it should have been called a null coalescing operator. It is not. It is a null-ish coalescing operator. And why is that? That is actually very cool. Now, in JavaScript, we have two kinds of values that can act as a null value. One is null, what is the other one? It is undefined. Now, undefined and null, we can safely say that null is null, right? But undefined, it is not null. It is null-ish, right? Like green-ish, blue-ish. It is not null, but it is null-ish. That is why it is called a null-ish coalescing operator. The actual coalesce part, it actually is borrowed from SQL, like in the 90s. That was the first time that this word was created. It was created by SQL. It is in the SQL standard. It was created back then, and it was created for the same result, for like null values. But since JavaScript adopted that in the year 2019, it changed the name to null-ish because there is null and then there is undefined to cover both of them. So that is why it is called null-ish, because we have a null and we have undefined, which is null-ish. And this is what it does. And I think that is it for this lecture. See you in the next one.
Hi and welcome to part 7 of Let's Get You Coding Challenges. In this section, we're going to talk about challenges for which the concepts were discussed in the previous section. Let's get started. Hi everyone, welcome to the first challenge solution for the unknown type. The challenge statement for this challenge says, what will be the value of the movie ticket price? Before taking a look at this, we need to start at the beginning. We have a variable called favorite movie and it has been type annotated to unknown. The value for that is a string. Then we have another variable, some movie, and to this variable we have assigned the value of this favorite movie. So the type of this is unknown, and the type unknown can be assigned to a variable of type any. And as soon as we assign this favorite movie that has a type of unknown to type any, this favorite movie at this point it becomes of a type any. And then when anything becomes of type any, we can assign that to a variable of type number, type anything that we want. And that is where we actually lose type safety. So when this has a type of any and we assign it to our movie ticket price, which is supposed to represent a number, now it represents a string. So the result of this, the value of movie ticket price is going to be the good, the bad, and the ugly. So this exact string is going to be the result. That is it for this challenge. See you in the next one. Hi everyone, welcome to the second challenge solution for the unknown type. The challenge statement reads that what is going to be the value of the song name variable, and we need to find that out. So first off, let's take a look at our first variable. That is favorite song. It has a type of any, and we have, a type of unknown clearly, and we have passed in a string of undia. I'm not sure if that is pronounced like that. Then we have a variable called song name, and then which has a type of string. We have type annotated to a string. Now, we are using a ternary operator, which in fact is a conditional. We are saying that if the type of fav song is a string, then return that. And we can see that it in fact has a type of string. So we are going to return that. And if it doesn't have the type of string, we are going to return an empty quote. So we are just going to return the favorite song. Let's go ahead and let's do that. So the value for song name is going to be the string of undi. That's it for this challenge. See you in the next one. Hi everyone, welcome to the third challenge solution for the unknown type. The challenge statement for this challenge says that we need to stop this code from compiling because there is some error-prone type annotation. We need to fix that error-prone type annotation. And let's take a look at this. What is wrong actually with this one? We have a product price that has a type of any, but we are storing a number there. And then we have a course name with the type of string, and we are assigning it to product price. Now, normally this would run because even though we are storing a number into this variable, because it has a type of any, it can be stored within a string, it can be stored within a number, within anything. So what we need to do is, this part is okay because course name, logically we know that it is going to be a string. But course price, since we know that it is a price, we are sure that it has to be of type number. So let's go ahead and let's fix that. So I'm going to cross this. We don't want a type of any. We want a type of number. Now, if you take a look at this in the VS Code, you're going to see like a squiggly, I believe it's going to be right here, where it's going to say type number is not assignable to type string. That is it for this challenge. See you in the next one. Hi everyone, welcome to the first challenge solution for index signatures. The challenge statement reads that what were the product's object log. First, we need to take a look at the type of that. So we know that this is an index signature challenge, but even if we didn't know, when you just take a look at this, you know that this is an index signature. Now, we have already talked about index signatures a lot, and we know what kind of limitations they are used to remove. Like, for example, if we have only types without index signatures, we can have one instance of a single key. But in the case of an index signature, we just specify like a generic key, like some sort of a key as a placeholder, and this is going to be the type for that literal key itself. And then this number is the type for the value of this key. Now, since this key is price, it has a type of string. This price could be, we could just write it price, we could write it whatever we want, as long as the value that it contains must be of type number. Now, since index signatures allow us to come up with this kind of flexible objects that we can have several different, we have already talked about all of this, several different properties with just one index signature, there is actually a limitation. Now the type annotation of the actual index signature is number. This is the type annotation of the literal word for the key that we use. That is price. When you have an index signature in an object and you want to follow it by other properties, those properties must always be of the type that is the type of the index signature. So the type of the actual index signature is number, the type of the value that it accepts, but the type of the value that this name property accepts is of type string. Therefore, this is going to be a type error. A type error. In fact, there is going to be a bunch of errors. For example, there's going to be an error telling you that the type of string is not assignable to the index signature with type of number. There is going to be another error that's going to say that this object is not compatible with this product. There's going to be another error that's going to say this can be assigned to the product. We can assign products to this object. And then at the end, you're going to see there is going to be an error that is going to say type number, I think it's number. Type string, sorry, string is not assignable to number. So there's like a whole bunch of errors because this is such a wrong thing when it comes to TypeScript. So if you have an index signature, the takeaway, the index signature is of type number. All the properties that are following it, they have to be of type number, the same type. Otherwise, there's going to be like a bunch of errors. So it's a type error. That's it for this lecture challenge. See you in the next one. Hi everyone. Welcome to the second challenge solution for index signatures. The challenge statement for this challenge reads that we need to create an object type that holds an index signature. Technically, it says create an index signature that maps a product's name, a string, to a product price of type number. And finally, of type number or undefined, I should keep that in mind. And finally, we need to create an object from this type. Let's see how we can come up with this one. I'm going to create the type. I could name it anything I want. I've named it product. So let's just call it that. This is not the important part. The important part is what follows. So we have type of product. Here is the index signature signature. So we want a product name that has a type of string. So name, which is string, which maps, this is a square bracket, cool. Square bracket, a string which maps to a value with the type of number. Let's write that, string. So the literal key, the literal letters that make up the key, they have to be of type string. But the value that the key holds, it has to be of type number. Number or undefined. There we go. So this part is done. Let's jump into the object. Let's create an object from this. I'm going to say const product, and we need to type annotate it to this product, and then I'm going to create 3 products. Now again, what is the key? What is the actual literal type of the key? It is string. So if I do TS, it'll satisfy it. If I do JS, it will be satisfied. And this is the flexibility that index signatures give us. With just one expression, we can create several different keys. And then I'm going to add remix. Now, these have a type of string, very good, but the values that they contain, they can only contain number values. So for this one, 10.99, 9.99. However, I don't know the price of this course when I release it. I'm just going to say undefined. Maybe by the time you're watching this video, the remix course is already released. So you might be saying, okay, there is undefined, but we have already fixed that undefined there. So that's it. This is the challenges solution. I am ascending. I'm not sure why am I writing like that, but that's not the point. The point is we have done it. See you in the next one. Hi everyone. Welcome to the third challenges solution for index signatures. The statement for this challenge says, what will the product object lock? Before talking about this, we need to take a look at our type. So we have a type of product, and we're using an index signature. The literal key is going to have a type of string, but it is going to hold a number. So far, everything is cool. Then we have a property, a single property that follows our index signature. The property name is number of students. What is the kind of value? What kind of value it can hold? It can hold a number. So at this point, type number and type number, they match. They are compatible. So our index signature is not going to throw any kind of errors. Let's take a look at the object. We have an object called product. We have type annotated to our type product from here. And then since we have this price, which is of type string, we can use any kind of string that we want. And I'm using the Flexbox course, but the value for it has to be a number. It is a number. And then we have number of students, which is of type number, which is also of type number. So everything type checks, everything is okay. And let's see what the result is going to be. The result is going to be Flexbox with a value of 1099, comma, the other property is going to be number of students, which is 4,200. This is going to be the challenge solution. That is it for this challenge. See you in the next one. Hi everyone, welcome to the indexing into object types challenges solution. The challenge statement for this challenge reads that we need to create a product type with a name property and a prices member, and the prices member is actually an array of numbers or a numbers array. Then we need to index into this type to with a product prices type, so we are indexing into it. And finally, we need to create an array of prices and lock it. Let's go ahead and let's see how we can accomplish this. First off, I'm going to create the product type product that is going to have a name and a prices property. Let me just close it right there. The name is going to be of type string. This is product. This is going to be of type string, and this is going to be of type an array of numbers. Now we could do the normal regular array syntax, or we could do the generic. Let's do the generic. So array of numbers. Very good. Now we need to index into this type with a type called product prices. Type product prices, and then I'm gonna put that there. Cool, let's write that. We have product prices. I'm ascending again, and then we need to reference that whatever type it is that we want to index into, and the only syntax that is available for indexing into a type is the bracket notation. Therefore, I'm just going to do the bracket notation right here. Now, within the bracket notation, the only thing that we can do is write a string, if that is a string. So in here, we're going to reference the prices array. There we go. Now we have successfully indexed using the product prices type into the product type. Now let's create our product prices array. That's going to be const product prices product prices, and the type annotation I'm going to talk about. And in here, I'm going to say 10.99 and 9.99. For some reason, my 9s look really, really weird. And the type annotation, now, since we are just assigning an array, we're assigning that to this variable, and which of these two types represents just one array? That is the product prices. Therefore, I'm just going to get product prices. That's it. That is it for the challenges solution, and then you need to log this as well. See you in the next one.